operations in Gibbon County and also in West Kentucky. Proud to be a part of this. I've been in the coal industry as an underground miner for about 16 or 17 years, and in the last 5 or 6 years, I've stepped out and done a little bit of advocacy for the industry, for Alliance through government affairs and public relations and that type of thing. So the interesting thing about my company is we partnered with University of Kentucky at our Dotiki operation to actually extract rare earths from the gob or refuse, if you will, at that operation after it was had moved on. So we have a little bit of knowledge about what that actually looks like. And UK was able to actually build a manufacturing, a small plant it's not scalable at the moment, but so anyhow, happy to be a part of it.
Good morning, everyone. I apologize for being late, and I don't want to blame my boss, but that's what happened. But thank you very much for being here. It's really thrilling to kick this off. It's extremely meaningful to the governor. It's extremely meaningful to the state of Indiana, but it's also really, really meaningful to the United States. I know that we've got some great presentations here. I won't go into too much detail. I want to thank Director Morrison for kicking things off in my absence this morning, but I also want to put into some context what our mission is here in the bigger picture. I'm often asked to speak in different environments today about energy and natural resources. And one of the things I'm always trying to drive home is that we really have a huge opportunity in today's world and our country, and we have to think bigger than ourselves, because this opportunity is a moment in time that I hope Indiana will really lean into and will take advantage of. And when I look at one of the slides that's going to be coming up in one of our presentations today, we'll see that on the graph, China contributes this much to the rare earths that we use every single day and all the products that we rely on every single moment. And the rest of the world gives this much, and the United States gives this much. And that's not acceptable, I think, to any one of us. And certainly the leadership of the country wants things to change there. And our governor wants us to be able to create an environment in the state of Indiana where we can identify the rare earth elements and materials that we have available to us, find ways that we can extract them, find ways that we can convene industry here to refine them, and then sell them for reuse. And that's just breaking down into the most simplest terms what we're trying to do here with this group. And so I want to welcome everybody to participate here, all those that are watching online. Please contribute any ideas. There's no bad ideas. Don't feel shy. Be here to participate in any way, shape, or form that you can, and we welcome your input. So thank you, and I'll turn it over then to Director Morrison.
Thank you. I'm sorry.
No,
I just wanted to say a big thank you first to a couple people. So Maddie Connor, who is our chief of staff with the DNR, she's done a great job putting this all together and organizing this, and she's really the tip of the spear on this EO. So Maddie, thank you very much for all your work. And then Holly Lawson and her team, they always do a great job. And so we're live, coming to you live right now, courtesy of the DNR communications team. So I appreciate that. And last but certainly not least, I'd like to thank Speaker Houston for allowing us to use the House Ways and Means room for today's meeting.
Thank you.
So, thank you.
Thank you very much. Okay, and now I think we turn it over to Reliable Energy.
Mike, there we go. Good morning, I'm Tommy Sutton. I work for Sunrise Coal Company. Been working now in West Kentucky and Indiana for 45 years, so Matt's got me by a couple of years. Always tell people that I've lived about half my life in Indiana and half in Kentucky, so I serve as an interpreter. I never know whether to laugh or be offended if I hear a Hoosier or a Kentucky joke, so kind of right in the middle there. So that's a quick little bit about me. How do I get over to my slide? Space bar here. There we go. So history of coal, my interpretation, it says by, but it could be random thoughts would be a better interpretation here, I think. Indiana coal discovered along the banks of the Wabash River near Terre Haute in 1736, quite a while ago. I like this picture mainly because you see the little black streak running there. There's your coal. That's called an outcrop. So if you see something along a stream, you see them now along the roads where there's a bit of cut, you'll see a seam of coal. Some people don't really understand that exactly how this works, but coal lays in beds like this. So this is how the coal was originally discovered along the Wabash. I thought that was appropriate. Figured they have probably flat boats picking up the coal, using it for local reasons. The Illinois Basin, you hear about it quite a bit. Well, what is the Illinois Basin? Well, as you see why it's named Illinois Basin. It pretty well covers the state. And it just kind of comes across southwestern Indiana. And on the right-hand side, you'll see a little map of Indiana. The blue represents underground mines. The brown represents surface mines. The Illinois Basin, I always like to describe it as a bowl. So if you think about a bowl comes up on the sides. That's exactly what the coal seams do. So the next slide, you can kind of see the different seams, how they're identified in the different states. The early geologists, they would find these outcrops in different areas. And it just so happened they found one near Danville. I think that was Danville, Illinois. Pardon me as I scrub through my notes here, but yeah, so they found down Danville, Illinois, Hymera, town in Sullivan County. There's your six coal. Wherever they happen to see this, most of the time the geologists identify these particular seams by the little town or community that was nearby. So you go on down, you see the different ones: Springfield, Heron, Servant, Sealyville. Sealyville's right outside of Terre Haute. So you're seeing some stuff that you can relate to. And notice some of them do carry all the way across. Some of them change names, they go across. Growing up in Kentucky, it was called the Kentucky No. 9 seam. And you see the 9 in the parentheses beside the West Kentucky. Interesting, when you get down to the 6 coal, or up to the 6 coal, you notice you got a Hymera and a Heron. Hymera is kind of unique to Indiana. The Heron coal is a prominent seam in Illinois, and it's called the same in Kentucky, except it's known as the Kentucky 11 coal. So working in West Kentucky, we mined the 11 and the 9. I come up here, they referred to it as a Hymera, but there was a little different split. So anyway, that's the name. I've also identified, so you think about the different seams. The air quality mines, the Black Beauties, was in the 7 coal. So was some of the surface mines. The Farmersburg mine mined the 7 coal. And then a lot of the surface mines in this area, like Bear Run, for instance, they're mining the 7, the 6, the 5. They've got multiple seams because they're moving all of that overburden same time. You go on down to the Servant, the 4 coal. There's been a lot of big underground mines. The Coal Inc. mine for years that supplied coal to the Perry K plant, that's the coal that they were in. So it was a good quality of coal, low sulfur. They loved that coal. IPNL was really hated when that mine shut down because of that. The Colchester, the Sealyville coal, that big Amex Chinook mine right outside of Terre Haute, where you go through that was the coal that they mined. Personally, I've been involved in upper block, lower block coals. I've mined those down around Dale, Indiana. And then I've also mined them up at our Coal City mine, our Clay City mine, right outside Clay City, Indiana. So you see these all around the outcrops. The Shady Lane coal, we mined near Switz City when I was with Triad. So here's a slide kind of showing the different kinds of mining. I'm going to start at the bottom, because when you think about the original underground mines, they really didn't know slope. So they either went inside an outcrop like you saw, or they drilled a shaft. So that's how the original mines got going. Then the slope mines came along a little later as people got a little more sophisticated with their equipment and things got bigger. You see the drag line off to the side on the surface mining side, example of Bear Run, some of those places. And then we'll also have what we call a high wall miner, or sometimes we'll go directly in off the side of the high wall, that's hence the name, and just mine straight across. And a lot of times those will only go in for a while. Vigo had a large one down south in Warwick County where they did a lot of that. Then auger mining has been a little bit of that. Drift mines, this is where there's really not a drift mine or a contour mine. We definitely don't have mountaintop removal here in Indiana. I personally like being a flatlander for the most part. So those guys in East Kentucky can have that stuff. And then the valley fill, that's just another byproduct of that. It was always interesting to me, though, that a mountaintop removal was a bad thing But then if you've ever been to Pittsburgh, Pennsylvania, guess what? They did. They cut off the tops of a lot of the mountains so they could build houses. So what's the difference other than you extracted coal? So I don't know how some of these things get the bad names they have. Here's a couple examples of what underground mining may have looked like back in the day. See the mule pulling it, and then look at that slide here. You see that in the 1830s it started. Underground production peaked at 29 million short tons, and we had over 22,000 coal miners. It's just hard to believe. But I've talked to enough people around like Bicknell, Indiana. They had a train there and they had whistles, and they tied those whistles in with which mine you were going to. So there were different mines, and if you heard two long whistles, your train was picking you up to take you to the mine, then bring you back at the end of the shift. It's pretty neat stuff. On the downside of it, we had over 800 people died in coal mining accidents from 1840 to 1913. There's an example of the old type of mining, a couple of entries running. They're just randomly shooting coal, bringing it out with their mules wherever they went. And then over time, we started developing better ways of mining. This is conventional equipment. So in the upper left-hand corner, you'll see a car, but down in the lower right-hand corner, that's a drill. And I apologize, some of the slides kind of got cut off on the end. But the old days, and I actually did this type of mining, conventional mining in West Kentucky at Retiki Mine, predecessor of Alliance. But you would drill into the face. You'd set then you have a cut machine comes and cuts an open cut at the bottom of the coal. Then you would drill holes into it, put explosives into it. The old saying, fire in a hole, that we actually hollered at. I've done it many times myself. Fire in a hole, wait for the blast, coal comes down. You take a loading machine, which is in the upper right-hand corner. Had arms going like this and loaded the coal into the shuttle car. You bring it back to the belt, brought it out. That was still mining in the early 80s. We still had that, but things were starting to change. This particular map here is of the old Ebbsville mine. This was in Sullivan County, just south of Sullivan. I kind of like this slide because I put in the Buck Creek mine in 1988, just to the west of this. The Ebbsville mine was mined by the Smith family. They actually own this. I can't think of Mr. Smith's name that ran the bank here. Anyway, I actually spoke to Don's dad is the one I spoke to in 1989. I'm drawing a blank on a nice old guy, but at the time, he had to be late 80s, early 90s. And he was talking about this mine because what was interesting on this mine was that the last map was 1933, but the records from the state showed they mined until about 1935. So I'm thinking, well, this isn't right, guys. So we did a lot of time and effort drilling a fence, if you will, all the way around this mine, found out where they went past it, and then knew not to mine into that because that would have been a bad day if we would have mined. Because we drilled a hole into the works of here, and this mine was approximately 300 foot deep. When we drilled that hole into the mine, water came up to within 18 feet of the surface, showing you if we would have mined into this, that would have killed everybody in the mine almost instantly. And I guess there was just a recent accident in West Virginia where someone mined into some old works. So following World War II, advent of large-scale excavation equipment made surface mining more cost-effective. The very top slide, and you've seen some tracks of this, and Kit will be speaking later, may have seen it too. Some of these old pits, they actually ran the track right down into the mine, into it, and they loaded it. So that's what they're doing. The second slide is more recent. That particular drag line you see is a walking drag line, but one of the early ones. I really like this particular slide because a gentleman by the name of Pat Boosie, who I had the privilege of meeting, owned a company called Comet Coal and Clay right outside of Switz City. Great guy. He came back from World War II with a buddy of his from Indiana, was a CB, looking for something to do. They met this buddy's, it ended up being his wife. They developed Comet Coal and Clay, and that was one of the shovels that he mined with. Great talking to him. Pat's since passed away. By 1965, surface mining accounted for more than 80% of the state's annual production. So you start to see the advent of the big walking drag lines. This particular machine is what the 2550, I think it is, that Bear Run. So this machine's still swinging, and it was built in the 60s, to give you an idea. So these things are great. When you're mining, you can mine large scale areas. If you think back into late 70s, early 80s, you had Amex Coal Company, you had Old Bend Coal Company, you had Peabody Coal Company, mining these massive reserves with these type of machines. So they covered a lot of territory. And these drag lines are invaluable when they're running. And the day you shut that mine down, it's one big dinosaur that has to be done something with. So the Surface Mining Control and Reclamation Act of 77, SMCRA, changed things a lot. So in this particular slide, I'll give you two examples. On your left-hand side, you'll see this, both of these slides I happen to know pretty well, and Kit knows it too. On the left side is the Freelandville right behind the Bethel Church. That particular was mined in the 50s. When I went out there and looked at this area was covered in pine trees. And I was walking around over these old spoil piles, and you notice every one of them was flat on top. And I thought, man, that is so strange. Well, come to find out, in 1950s mining, their reclamation plan consisted of grading the top of the spoil pile at least 10 feet wide and planting it in pine trees. So that's why you see a lot of these old things like that. Found that very interesting. On the right-hand side, you kind of see a couple of the hog barns up there. That's Sullivan County. That's the Bucktalls, or had it at one time. On the left-hand side at the top, that was surface mined by Freelandville, as was the part to the south. So there's some unmined and mined territory. One of my old favorite tricks when I'd go to the mine was taking somebody, that was questioning about the evils of surface mining, how they didn't put the ground back. I always had one particular spot I stopped on the road, and Matt, you may have done something similar. I go, there's corn growing on both sides of this road. Tell me which side I mined. And they'd go, I don't know. That's what you wanted to hear. Yeah, so they didn't, but it was just a point that if mining is done correctly and you reclaim it, the average person and the farmers, they really don't know. It takes a while. I'm not going to tell you it's going to come back in a year. But if you reclaim that thing, give it 5-6 years, a good farmer, you won't know the difference.
Of course you.
A story to tell on that very thing. It was Secretary Duffy. We flew from Indy to Evansville, talk about the bridge crossing the Ohio River. But along the way, I pointed out all the coal mines along the way. What, that was a coal mine? What, that was a coal mine? What, that was a coal mine? Every one of them. It was cornfields, whatever it was. And you see that drag line? That was mine. And, you could point it out and see the progression of reclamation. The old stuff that was 4 or 5 years old, it was farmlands, that are forest, whatever was prescribed for that piece of property. And the people on the helicopter, whether it be Secretary Duffy or even my own staff, what, that's a coal mine? They see the pictures and their memory is going back to the 1930s pictures of the mounds that you can't traverse. But mining today has come a long, long way. I'm very proud to be part of that. And talking about deaths and safety, I mean, one of my proudest achievements of all is 47 years in the mine, and I never had one death on any of my mines, not one. And I can tell you that's the proudest achievement in all. And every coal miner has embraced the safety piece going forward. Safety is the start of every single day. And when I talk safety, I don't mean just to the miner, I mean to every person in the community. Very, very important, whether it's blasting, whether it's dust, whether it's whatever that's leaving that mine. And the coal miners of today are 100% into doing it right. So I just want to add that I'm loving your presentation.
Appreciate the input.
I'm loving your presentation, but I can't brag enough on the people that are out there getting the job done, providing energy for our state. And I'm hoping this council here is going to bring some new life into what these guys do every single day. I can't speak enough good about what they do. Thanks. Sorry for the interruption.
Oh, that's fine. Well, the next slide just shows some typical equipment used. You can see the large bulldozers. Those are D11s there. The smaller shovel there is excavator, excuse me, is loading coal into the back of the 777. In the background, you can barely see an 1800 hydraulic shovel that's moving overburden. For us, I work for smaller companies typically rather than, I worked for Peabody when I first started, but most of my experiences with Triad Mining, Sunrise Coal, this was the smaller hydraulic excavators. We could go in on, a couple of 100 acres and mine it out in 2 or 3 years. I was telling somebody just the other day, I started adding it up. I personally have worked at over 30 surface and underground coal mines in my 45 years. Now, don't get me wrong, I wasn't there 8 hours a day, but a lot of them, but as an engineer or management, I had something to do with those mines, and quite proud that a lot of them have been right here in Indiana. but we used equipment. We might have 30 to 50 guys. The guys knew where they were going to go. It'd be, where you send us next? And normally those guys would drive anywhere from 20 to 50 miles to the next mine that they'd be working at. This was an example. This particular mine was at Triad Mining at our Freelandville mine. We were mining the 6 and 7 coal, and we had already had Freelandville underground. We needed to expand. So this was the Freelandville West mine. So, and pardon me, if this thing still pick me up if I walk around and point. Anyway, you see the belt line going into the middle of it. Off to the right, you'll see a fan. That's a blowing system fan. So air is being blown in. That other entry is part of our intake escapeway. So that was left so people could come out of the mine safely. The other side was our primary haulage. And then on the far left is return air. So I like this particular slide because it does show you basically all the components that you need for an underground coal mine. You got to have a place for the people to go in. You got to have a place for the product to come out. You have to have some good air going in. You have to have a place for the bad air to come out. So that's kind of what makes up the mine. There's an example on the left-hand side. That's our Sunrise Coal's Russellville portal. That's for men to drop in. You can see a cage full of men on the upper right-hand side. And on the lower right-hand side, that's the slope at Oaktown number 1 that some of y'all have had a chance to go under at one point or another, and that's what the guys do every day. That slide, so you can see that we're actually using rubber-tired equipment to go in. There's different types of ways you can put the slope in. The original mines I worked at, the slopes were about 16%. That's too steep to walk. I'm sorry, 16 degrees. 16%, 15% is 8 degrees, and that's what you can drive. 16 degrees is more like double that, and you can't drive that. You have to have a hoist actually pulling you up and down there. That's a continuous miner in action. There's another couple of pieces. You see the roof bolter off to the right. That's called a double boom bolter because there's 2 men are applying roof bolts together. And then on the car, and I said men, but there are women that work at our mine as well. So pardon me if I only say men, just force of habit. That's an example of what the belt line looks at our Oaktown mine on the left-hand side. Notice how white it is. Now, the gentleman that runs our mine, Matt Dow, loves to take people down underground. And when they first go down there, he goes, when he takes it down, he said, most people don't realize that coal is white when it's underground. It doesn't turn black till it comes out. Of course, everybody gets a good hee-haw. And you get people occasionally will listen to that thinking, well, is he really telling me the truth? That's just a well-rock dusted mine. And this is part of the regulations that you have to. On the right-hand side, you see what can happen when the roof doesn't come in. You'll notice that there's some roof bolts, there's a light shining there, and there's some chunks of rock and fell. And on the bottom, you see that wire mesh. We call that a hog panel. And that was what it used to be used for. We use those to help support the roof. So in addition to the roof bolts, that's trying to hold the loose rock up there together. There is an example of modern ventilation, and I think I'm probably already over on time, so I won't. Okay. Well, anyway, what about everyone in the underground business in Indiana does now? We use what they call split ventilation. So in the middle of that blue line, that represents the belt. So on this map, we are mining, if you will, from the west to the east. So it faces advancing. You can see a feeder on there. And then on the yellow, that's how we travel in. The green is the escapeway. So you'll notice some green arrows. That's fresh air, comes up near the middle, splits. At that point, we got a continuous miner and cars on one side hauling coal back to the belt, on the same thing on the other side. By splitting the ventilation, everyone's under fresh air when they're mining. That was one of the rules that came out of the 1970 Act that I'm talking. So no one's under the chance of getting coal dust, secondary dust from a different machine. It's cut down on the amount of black lung, and then also potential with explosions or something like that. Okay, this right here is interesting to me. Of course, I see it every day, but this is an example of Sunrise Coal's Oaktown number 1 mine on the right-hand side, Oaktown number 2 on the left-hand side. Notice the yellow ribbon running through the middle that separates that. That's a sandstone channel. That's the Galatia Channel, or what most people call it here. That's where the river flowed through the coal later. So the coal had been deposited, the river comes around, wipes out the coal. This thing meanders through Indiana, is right alongside the Gibson mines. It goes over into Illinois, so it's well known and documented. So on the right-hand side, our mine 1 is active right now. We've temporarily shut down mine 2. But on the mine 1 side, the coal was a little higher sulfur, black shale, immediate roof, limestone above it. Clean water environment. Black shale was an ocean environment. the higher sulfur coal is associated with the more marine, the ocean environment. So that gray shale kind of protected the coal. So it's not dramatic right here, but it is down at Gibson mines. Their mines are low sulfur. Ours, it's like 3.5%, 3%. The other little blue line you see running down through there is the Wabash River. So that part that you see on the left-hand side, that's actually in Illinois. So when I told you about Russellville, we mined underneath the river and then came out and put another portal into our mine on that side.
Just one comment, Tommy. So that exact ribbon that he shows is all the way down in Gibson County. And that's why we have a Gibson North mine and a Gibson South mine. That same exact parting forced us to put another mine in on the south side of it. So it's kind of neat to think about how coal was formed, I guess.
And there's little rivers and streams that come into it at different points that affect their mining.
So
This slide, there's actually two pictures here. On the left-hand side, you see the rail loop of Oaktown. So on the far left side, that's the main line CSX that runs all the way from Chicago down to Nashville, L&N Railroad. I guess that's Louisville, Nashville. But anyway, that's the main line CSX Railroad. Our particular loadout has two tracks parallel to it. That was a requirement of the CSX Railroad. I don't think we intentionally wanted to do that, but it really works out great because they'll bring in a train load of cars. So a little random fact for people, when you hear of a unit train, everyone I think knows that's 100 cars. The original cars were 52.8 feet long. So a unit train was 1 mile long. That's where they kind of worked out. Now they've expanded a little bit, but we can get up to 140 cars on each one of our loops. So we can hold, 2 trains worth. Well, how much is that? It's about 26,000 tons. In the middle, you'll see the different coal piles. You can kind of see a belt line comes up and then it drops coal down. And it goes in a conical and then there's an underground reclaim tunnel that loads the train. These trains are loaded at about 2,500 tons an hour. So in about 4 hours, we can load a train and get it out the door. Trains in our part of the world are the main transportation thing. We were talking a little bit about ports and stuff earlier, which Matt, you happen to deal with in your present position. But in our part, we're kind of land bound. So trains are our primary way of moving it, though we do use trucks as well. On the right-hand side, you can see the big lake. That lake is about 100 acres that you're looking there. That is in the middle of our refuse pile. So if you ever drive around US 41, you get near Oaktown, you'll see a small mountain off to the side. It's about 60 feet tall. That 100-acre lake is on top of it. Most people are just amazed when they hear how much water is actually up there. And then we're slowly filling that up. So up on the north end of it, that's slurry that's beached, and we're slowly filling that in. We'll eventually convert that fully to a refuse pile because the majority of our slurry now goes underground. We've got permits that allow us to pump the fine coal back down into the mine. So that's been beneficial and it takes up a lot less space. So that's working out very well. So eventually we'll do away with that and take all of it underground. On the right-hand side, you see the 2 box cuts. So they're slopes, but when they originally, Vectren put these mines in, when they put those mines in, they cut through the surface and down into the rock, then started their slope. That's why you see the small box cuts. And then that's our warehouse and main building. On the left-hand side is our preparation plant. And now you see there's one belt feeding where it divides into 2. So we got 2 different plants there. The rotary breaker takes it over up on the upper side. There is a hopper where the refuse falls and it's taken by truck up to that pile that you saw previously. Over the past 5 years, we've lost over 1,000 coal mining jobs in Indiana. As of the end of the second quarter 25, there are currently around 1,800 coal miners. That's all that's left. If you remember earlier, 22,000, which we don't want to go back to that number because that was pretty tough work. And now we're down to 1,800. Nearly all Indiana coal is used for electricity. Peak year of all types, 2013, right at 40 million. We've averaged around 21 million over the last few years. I found this last one interesting. In the last 180 years, Indiana has produced 3 billion tons of coal. Amazing. 180, basically from the time we started mining commercially.
So one quick point on that, because I'm going to toot our horn a little bit. So we still produce about 50% of the electricity in Indiana with coal, and a lot of that coal comes from Indiana. And so with about 1,800 people, you're able to produce enough fuel to roughly produce 50% electricity in Indiana. And so one of the things that I don't know that gets publicized enough or enough credit to the industry is, even though we continue to shrink, we also modernize, we get more efficient, we get more productive. The productivity of the modern day miner, coal miner, in underground mines particularly, but also surface because of drag lines and whatnot, is miraculous almost. And that just doesn't get talked about enough. So as a guy who spent a lot of time in underground mine, I'm going to toot our horn just a touch.
Tommy, first off, this is a great, yeah, if you don't mind, it's a great presentation. So over the last 5 years, 1,000 coal mining jobs lost, and we have 1,800 coal miners. How does that translate into the support industry for the coal industry? What's the impact on those jobs?
You know, I don't think it's significant as you probably would think, because we still do. And a lot of our suppliers, for instance, is Davis County Block produces a lot of our cement block. They've got other things. Now, some of the stuff is no doubt affected more. McAllister, Caterpillar dealer down in our area. At one time, that Washington store was one of their biggest one. Matt, certainly knows that when you buy a D11 now, $3-4 million, one machine to buy. So major differences. That thing used to run 24 hours a day. So to your point, Alan, nobody's necessarily gone out of business. I'm sure some have, but some things are changing a little bit from what used to be main suppliers of mining. They've realized that they can't rely on us at this point. They've had to branch out, but they sure come back to us quick as they can.
So I'll make a point on that, because we directly deal with it in multiple states. It's almost impossible to be a small mining company anymore, because if you don't have the scale, which Alliance, we do have the scale, the vendors. So to Tommy's point, some of the common things that can be utilized in other industries, it may not have impacted those folks too much, but folks who make coal mining specific equipment and supplies, roof bolts and things like that, it most certainly has had a huge impact. At Alliance, we now produce a lot of our own roof bolts. A lot of the technology that we've developed in-house is because we have to, not because we necessarily want to. So it has had an impact on the actual coal mining industry. And to be perfectly honest with you, it slows down technology, because what vendor, what machine company is going to try to automate mining equipment for the few operators that are left? So when we think about the next step in mining, it's probably going to fall back on the shoulders of the very few that are left. And that research and development is definitely much slower than it would have been if we still had the kind of production that we had even 10 years ago. So.
And also, I have a question, Tommy. What about the communities, not just the mining suppliers, but the communities in the areas where the miners have lost the jobs, the schools, the cafes, all of those just economic impacts that happen in those communities?
That's one of the, I'm a small town guy. Ryan and I were talking coming in here. Indy's a nice place to visit, but put me back in Vincennes. I mean, I'm perfectly happy there, which Vincennes is a big town for Knox County. It's the little spots, Freelandville I'll pick on because I know that little community pretty well. It has an impact. Definitely, an average coal miner at our mine is making anywhere from $60,000 to $150,000 a year. You don't leave for too many jobs in Vincennes or go to too many jobs in Vincennes, Indiana that are going to pay you like that. Plus, we have full benefits. I'm getting ready to retire. I've been looking into Medicare. I've never had to worry about insurance in 45 years of doing this. It's kind of like, huh? You mean you have to worry about this? You have to make decisions? This is new to me on this thing. So those are the things, Suzanne, that really scare me for our particular county. And Knox County is lucky compared to some. Sullivan County's kind of struggled with, and Hallador buying the Merom plant. Are we saints? I would like to think so, but a lot of people would disagree. But Sullivan County's been very dependent on surface mining. They've got the power plant. Now there's other types of power plants or data. There's all kinds of things they're looking at. So, and then different counties, Pike County was totally dependent on mining. So I do worry about the little towns because I really like little towns.
Tommy or Terry. So the 1,000 coal mining jobs that have been lost, that's because decreased demand for coal?
Yes.
Yeah, I think, well, and Bruce is here, he can help us, but I think it was what, around 2015, 16, when the US produced around 1 billion tons of coal, and now we're probably producing about 400 million, give or take. Indiana, I think our biggest year was what, around 41 million?
Just under 40 in 2014.
So 2014, just under 40, and now Tommy just said we're about 20, so about half of our peak.
And I don't know if you guys know this, but how much of our coal, so we're focused right now about the
Production.
the production, which is very profound. Good point about the 50% of our electricity is coming from coal, 1,800 miners. We're exporting coal outside of Indiana?
Yes.
Yes.
Sunrise Coal, and I know Alliance does too. We've got one of our main customers is in Florida.
Yeah.
So yes, we export a fair amount.
If the demand wasn't diminishing, we have enough coal. Is it fair to say that we could power 100% of our electricity and then some and continue to export if we really wanted to?
Yeah, I think so. It's a little bit more of a technical question than that, because really what it gets down to is, can the plant burn? What quality of coal they want?
Yeah.
There's some pollution controls. So when you think about Powder River Basin coal that comes into Indiana from Wyoming, or the Powder River Basin, which is in that Wyoming area, it's a lower sulfur coal, and some of our Indiana plants did not put scrubbers on, and so that allowed them to keep running. However, the sheer volume, yes, we could do that, and we could export. Yes.
If I may, Senator, the question and point was about lowering demand, and that is accurate to say, but it's not a market demand that happened. It was an imposed demand from the federal regulations. So that's a different scenario than just it's not wanted anymore. And yes, absolutely, you're right. We were up at 90% coal when we were the 4th lowest cost of electricity state in the country. And then as we've decreased our reliance on coal down to 39% as part of our mix and energy generation, we've seen our cost of electricity go up so that we were last year at number 28. This year we've come down to 24, as I think the rest of the countries continue to see a growth in their energy cost as well. So if we're talking about the history of mining, which we are, I think that's an important point, that the federal government really regulated and influenced the demand rather than it was a market demand issue.
Yeah. So on that point, we've closed over 5 gigawatts of coal-fired generation in the last decade. And so in Indiana, we have thermal coal. We should probably make that point. There is metallurgical coal that you use for steel and some of the, I guess, for the steel mills. But for us, it's all thermal. So when you closed 5 gigawatts of coal-fired generation, well, then our Indiana production certainly reflects that.
So here's maybe dumb questions, but when we think about both R&D and the development of technology and equipment and other things, and on the workforce side, well, first of all, what does the training look like? What does the workforce training and preparation look like for someone going into coal mining today?
So we hire new people in. I guess, how do we train them? There's a pretty rigorous program. A lot more of it's safety oriented when you first come into the mine. So before you even can become an underground coal miner, you have to go through 40 hours of training to even set foot in the mine and then start your program. Then you have different goals as you go along. So there's pretty extensive. And as far as the machinery, a lot of it, some of it, the games the kids are playing on videos, or that's probably as good a training as any. That continuous miner I was showing you, that's all remote control.
Right.
So
yeah, so that was kind of where I was going. So on the workforce and training side, are you pulling most of these kids right out of high school? They're coming out of high school and going to you?
We have a good mix, but we do get a lot of people straight out of high school. There, at one time, VU and Ivy Tech, I think, as well, has offered 2-year programs.
Right.
But the thing, at the time when they were offered the program, there was such a demand for the minors. Unfortunately for the kids, we didn't even allow them to finish the program because we're pulling them out like, hey, we got to have you now. So in fact, I had one kid, I told him that I would not hire him unless he finished the program.
Right.
He finished it, and then the day he did, he took the job. But,
So from a competency standpoint, and then I guess that was going to be the question on the R&D side, as we think about the continued evolution of the industry generally, how transferable are those skills to outside of coal, other sort of energy industry applications and the technology?
there are a variety of tasks, and some of them, for instance, a roof bolter. That's a tough one to say, hey, I'm going to teach you this roof bolter, so you're going to be able to roof bolt in downtown Indianapolis. On the other side, I have a young gentleman that worked with me that had his informatics degree from IU. Couldn't find a job he enjoyed at all. He came to me, we were talking about it, and he asked if there was anything that he could do that he could work at the mine, because we were making more than most people at that time with that degree. He came in, I said, the best thing you can do is get a maintenance and your electrical card, and you'll go wherever you want to go. And I still stand by that, because that gentleman now runs one of the FedEx plants here in town as far as the maintenance end. He's in charge of all the electrical and maintenance. Coal mining, we have high voltage there. We work routinely with 1,000-volt systems throughout the mine, and you're dealing with three-phase electricity. Most people do not learn that unless they go out into the working world. So to answer your question, a lot of our miners now work for Toyota, steel plants, FedEx. They work at these places that need these large things. Bulldozing, the type of stuff out on the surface, those skills are transferable to any kind of construction job. And even the guys underground, I don't want to diminish what they're doing because, like I said, a roof bolter. But if you can operate a roof bolter, that gives you, and you show up for work every day of the week, that shows you've got a good work ethic. We make these people rotate shifts. They'll work 2 weeks days, then they go 2 weeks on seconds. So they learn how to work. We drug test routinely, randomly. So we got a good, clean workforce. These are not a bunch of derelicts. Coal miners sometimes get this reputation of being uneducated, dumb people. No, that's not the case. These are some of the best people that, for whatever reason, they don't want to go to college, or some of them go to college. I get so sick of that. Some people go, yeah, I don't want my son to be a coal miner. I want him to go to college. I go, I've got a master's degree. I'm here with you every day. Don't tell me you want to get your son or daughter above this, because what magical job is above it? I don't know.
I guess I would like to add to that. I've had so many people that were coal miners. Guess what? Teachers. No, it don't work for me. They came to the coal mine. I've had people that were coal miners and ended up being teaching in other areas, whether it was at a McAllister's or whether it was at any kind of facility that has heavy equipment. They ended up being trainers. They ended up being a lot of different things. And guess what? I started out with a shovel in my hand, and right here, I'm here today.
Yeah.
High school education. Look, there is not any place you can go, I think, like a coal mine, learn the skills, learn a trade, and day number one, start out making, $60,000. That's on the low side. Most of them are in the 80 to 120 range every single year. And they have good insurance, good benefits, can do whatever they need to do for their families. And their skills are absolutely transferable. I have not seen very many unemployed coal miners saying, I can't get a job anymore. The mine closed down. They're gobbled up like that. Nonstop, they're gobbled up every time. So I think, Tom, you said it best, the work ethic and the safety initiative drives that big time. And what company or corporation out there is not working for safe workers that want to apply themselves every single day? So I think these skills are 100% transferable. I don't care what you're going to. I think they're very transferable. And like I say, when I first started, call the man's world. By the mid 80s, I had women in them 200-ton trucks that, guess what? Everyone wanted to follow the female. That truck didn't have tobacco spit in it. That truck was always clean. That truck was well taken care of. The ladies that I had driving were a tire on one of them trucks is $25,000. So guess what? I had less cut tires. I had, better care for the machine. I'm telling you, they were a very calming effect on the male workforce. I was very happy to employ many of them, and I had a lot of them in leadership roles. I can't say enough about the workforce and the work ethic of the people that were in these jobs, and 100% transferable, just from the work ethic standpoint and the safety standpoint. I guarantee you they were employable every day of the rest of their lives.
Not to belabor the point, but I just want to make two quick points. So we unfortunately had to go through a layoff a few years ago, and I reached out to the local workforce board and said, it'd be great if we could put together a job fair for these guys that are going to lose their job. And but I don't want to insult them, because I really get annoyed by what people think about miners. Miners want to be miners. Nobody's forcing them to be a coal miner. Like, I want to be a miner. I have a degree from Indiana University in education. I taught. I was a teacher. I love this industry. I don't want to do something else. But when we had that job fair, the area in our area, Toyota showed up, Sabic showed up, GAF showed up. And why? Because those guys are, one, they can operate heavy equipment, most underground miners. Two, they're used to working in a hard environment with not necessarily a lot of tools and things at the ready. One thing you'll find out about a miner, they can fix about anything with a roll of tape and channel locks. But anyhow, so yes, the workforce is transferable. The training is light on the front end, but you have certifications that he mentioned about maintenance and other tasks that require certification to do in the mine. So I think the biggest takeaway for me, and the easiest way for folks who haven't been in the industry to understand it, is think about, particularly in underground mining, you're building the city every day. Like, no one goes underground but an underground miner. So whether it's installing freshwater systems, dewatering systems, conveyor belt systems, the high voltage that he talked about, everything that happens underground, a coal miner does. So it's not just about extracting coal with machines. In fact, most of our employees are support folks building the city, if you will. So.
If I may real quick, take an opportunity to jump in. I think we've hit a whole lot of really incredible points. If you think about it, we're talking about jobs, we're talking about skills, we're talking about coal mining, which I'm obviously a fan of. We're talking about power generation. If we're looking at this from a larger view, right, it's not just the amount of skills we have already or the amount of skills we're going to need, but if we're talking about opportunities in Indiana, the whole point we're here is to recover some of these things and actually get to making a revenue stream, providing some opportunities for folks that may be unemployed, providing some new skills. So it's a larger scale here of what we're trying to accomplish. But what do you need along with that? You need power. You need generation to support all that. Natural gas is great. It's a great opportunity. Solar, it's great. But when we get to base loading, we talk about manufacturing, we talk about doing new things, you need a solid base load to support those opportunities. So there's a lot that feeds into a lot of this as far as either trying to bring opportunities here to the state, supporting coal mines for sure. I mean, we're a coal-fired power plant, so we're in the same boat here. But there's a lot of cost to upgrading this system that we have to try and bring in either natural gas, solar, wind, whatever we want to come up with. But I just hope that we can put all that together as a whole: more jobs, more opportunities, more manufacturing, more power generation, that sort of thing. So a lot of good points, but I think we got our work cut out for us for sure. So
I think so too. Well, two slides here shows the production of 24. As you can see, if you look at that very closely, the number of mines underground 4, number of surface mines are 8 for a total of 12. We put out 20 million tons. And then 25, notice the number of mines now are down to 8. One of them, which is one of ours, mine number 2, Oaktown number 2, is shut down temporarily. And then off to the side, you can see I put the names of the active mines: REO Antioch, Gibson South and Francisco in Gibson County, Oaktown 1 in Knox County, Log Creek, which was an old Triad mine, and now Loudermilks are mining it, I think in conjunction with Alcoa, some of their production. REO Charger has shut down. Bear Runs in Sullivan County and Wild Boars in Warwick County. noticed up on the upper right-hand kind of talk, what we were talking about on the fatalities, we've had a total of 12 over the last 20 years. That goes from 2025 to 2005. So a total of 12 fatalities. And one thing that always kind of bugged me, and unfortunately I can't say what Matt did. I've been around, so there's been probably 3 fatalities over the years at different mines that I've worked at. But you know, the thing about it is one of the most recent ones at Oaktown number 1 was a traffic fatality anywhere else. He was on a man trip and he got on the side and it rolled over and he got pinned underneath of it and unfortunately he died. So I have to remind myself when I look at other fatalities, we always have this black eye, if you will, around coal mining because of people dying. Well, unfortunately, people die in accidents in whatever you do, and none of us want that. And we go out of our way to stop it. So I think now if you look at dangerous occupations, I don't have that actual statistic available, but coal mining used to be number 1 or 2. We're way down there now. There's a lot of industries. So anyway, this is a longwall shear. I threw that in there because I'm going to mention it here a little later. This is another way of mining underground. There, to my knowledge, there's never been a modern longwall mine in the state of Indiana. I really doubt there will be unless something happens in maybe in Posey County. There's some thick coal down there, large tracts. So what's the future of coal mining? Indiana has approximately 57 billion tons of unmined coal, of which nearly 17 billion is recoverable using current technology. Of the mineable reserves, 88% is recoverable by underground. So the big surface mines are kind of going on the wayside. 12% recoverable using surface mining methods. Just a few little points here. I don't think longwall mining will ever be significant if it even exists in Indiana. Current room and pillar mining working well for the people that are there. I think we've got several years. I think Gibson's got several years. Francisco, I know they've got a part they can develop that might extend the life of that one. So the existing ones, and there's some other reserves that we're aware of. There's no new coal, so we all are competing for the same the coal reserves. I think our large surface mines, a few smaller ones will continue to operate. Then I made the comment, does our future rely on our past? It's kind of what we're talking about. Coal mine methane, we actually are pulling methane out. Now we're kind of using this, the greenies, if you will, and California will pay for methane carbon dioxide. So if by burning methane, we're reducing our CO2 footprint and we can get credits for that. So we burn off that methane and we're compensated for it. So it's great. On the other hand, that methane could be used for some other purpose too, but we're using the system and I think about everyone's doing that now. The extracting rare earths is what we're all about. From ash, refuse, slurry ponds. We've got that, as I pointed out earlier, that giant mountain beside us, that's roughly 55 million tons of material right along the railroad, right on an area. You wouldn't have to permit a new green area. This is something that's there. I envision that will be mined at some point. Now, is it rare earths? I don't know that it's rare earths. But what I do know is that thing is full of pyritic sulfur, which is a bad thing from a drainage standpoint, but there's a demand for sulfur at all times. Plants need sulfur. People add sulfur. One of the local farmers said there used to be the power plant at Edwardsport. He never had to add sulfur to his crops because it came from the stack. They shut that down and converted it over. Now he has to buy sulfur. He just ticks him off every time he thinks about it. And then I think in those gob piles, there's going to be minerals and elements that I can't even think of. So I think there is a lot of opportunities, and I'm sure they'll come up with new methods of mining where maybe we'll do it with water or something. People won't even go with some of these little thin seams. So more of that 57 billion. But I do think there's a lot of hope for the future for coal and the byproducts. I think that's one thing we're all starting to see is a lot more use of what was refuse at one point is now something that you can actually use. So I threw that in this is from our Merom power plant. Hallador Energy owns our Merom power plant. These are different products. As you can tell, the guy that labeled it, which happened to be me, was talking while he had this particular photograph. But I like this photograph because it shows you all of these products. There's somebody who wants almost every one of them. Mm. The wallboard gypsum, they love that. The ag gypsum, like that, we don't get rid of all of it, but we move a lot of it. The Positech, that is actually your fly ash mixed with lime. And the idea is that it sets up so you can store it better. But I really think at some point that may be where some of the rare earths are coming from. And some of the other people will probably hit on this more later on. And then the bottom ash is just the coarser stuff. There's a demand for that right now too. So that's what you see, the refuse stream coming from a modern coal-fired generating plant. I'm Tommy Sutton. I talk a lot, but thankfully I have plenty of help from you guys. So.
Thank you very much, Tommy. That was really interesting. It was great to hear about the history of mining. And I think a couple of things. First of all, with the demand for electricity increasing, we've seen the third quarter results from Hallador Energy and Sunrise Coal. Amazing. I mean, that is amazing increase. But also looking at that history tells us how we can apply that to our extraction. So as we're looking at building this rare earth model for the future of Indiana and looking at recovering rare earth elements and materials, we have a rich history in extraction and taking what we've learned in our history in extraction and applying that to, in addition to coal mining, other materials. So thank you very much for that. We appreciate it. Up next is the DNR. And do you want to do the introduction there for your
Sure.
staff? Thank you.
Yep, very happy to have Kit Turpin here to talk about our AML program. And Kit, the table is all yours.
All right, I gotta walk back here first. Little visualization for everybody.
Madam Chairman or Mr. Sutton, is the deck that you just went through, is that something you could share with the group?
I certainly.
You'll circulate it? Okay, perfect. Sounds, all right. Thank you.
Yeah. By the way, I'm sure Maddie's been in touch with everybody here, but for logistics and everything, but she's our go-to, and thank you to Maddie for everything. But if you need some copies of anything, Maddie's our person for that. She'll get it to you. Okay. You're welcome. Thank you very much.
All right, thanks for having me. Not used to sitting down when I'm giving presentations, but we're gonna make it work. But I do appreciate the opportunity. My name's Kit Turpin. I am the director of your abandoned mine land program. I grew up in Gibson County. My dad was a coal miner. My mom worked in the courthouse. I grew up playing on coal mines, and now I work on coal mines. Spent some time with the Park Service doing kind of rehabilitation projects on small pieces of land. And yeah, I do a lot bigger ones now. I've been with the program for about 18 years. But yeah, kind of open it up with this just to let you all know this is kind of typically what the AML program, what our product is. You know, a landowner will call in, they've got a high wall, maybe a shaft, and I should say this is all abandoned mine land. These are coal mines that operated before any regulation. But there's a lot of stuff that was left behind, but a landowner may call in, they've got a safety issue. And yeah, we kind of prioritize the sites according to the safety problem that's present. This picture here, the kind of brown lines are the grades that were there. The red lines are our engineers' proposed grade lines. And it's a lot more than just regrading. Our engineers put a lot of thought into how to control the hydrology of the site and make sure that we're not having any acid mine drainage problems. So I'll say AMD a lot during this presentation. This particular site, it had an AMD seep kind of coming out along the highway that was on the north side. There's a small pond on the right side. The Pleasantville Community Building is right there on the side of that project, and we backfilled a high wall there and along the back side of the site and regraded everything. And yeah, significantly reduced the acid mine drainage coming from the site while eliminating the safety problems. So that's kind of what we do and what we're typically looking at on our sites. The goal of the program is to address health, safety, and environmental issues on abandoned mine land. And the term gets tossed around a lot, and I hear it a lot from the public. Like when I say abandoned mine land, I'm talking about, just on the slide here, the sites that were mined. The main thing is the sites that were mined before the Surface Mine Reclamation and Control Act of 1977. There's, permitted mines. Sometimes they release the bond and some folks will come in and be like, well, this mine's abandoned. In my terminology, it's not abandoned, it's reclaimed, and everything's hunky-dory out there. But the funding that we operate, Reclamation and Control Act, and more recently, Investment and Jobs Act that was passed in 2021. The sites that are eligible for this funding, like I said, the sites before the Surface Mine Reclamation and Control Act, there is some leniency for sites that were mined between 77 and 1982 with inadequate reclamation, and sites that were from 77 to 90 where the bonding company actually failed. So there's no bond left to do anything on the site. And of course, in the unlikely event that the bond actually fails on an active mine, we take the bond, or the mine fails, we take the bond and we do the reclamation. Little side note, we would potentially be able to work on hard rock mines that would be like limestone, sand, and gravel if the governor issues a letter to authorize use of coal funds for those sites. Our authority comes from the Surface Mine Reclamation and Control Act, Title IV, IC 1434-19, and Infrastructure Investment and Jobs Act. When they passed the Infrastructure Investment and Jobs Act, there's kind of an important part of that. On SMACRA, we put about 30% of those funds back for doing acid mine drainage problems later. We got an interpretation of the Infrastructure Investment and Jobs Act that said we couldn't do that with that money. Our governor was co-sponsor of a bill to kind of fix that and gave us the STREAM Act. So we are also able to put back 30% of that money. He did that when he was a senator. Office of Surface Mining Reclamation Enforcement is our oversight agency. So everything we do gets the okay from them. And I should point out, anything, the sites that were permitted and bonded are not eligible for the funding that this program gets. It's very important. Kind of overlapping with Tommy a little bit here. Got a number of maps. We're in the Illinois Coal Basin, southwest Indiana. Already Tommy's map was real good, and that's that, the top map there shows where the Illinois Coal Basin is. Most of our problems occur where the coal is really shallow. So when they started mining, those were shallow mines. And when you get a subsidence in a shallow mine, you get a lot deeper hole than you get in a deep mine. We have about 19,000 or 1,900 sites. Any site that we do, the Office of Surface Mining Reclamation Enforcement has to approve that site, and then for it to be entered on the inventory, and then they also have to approve the work to be done out there after we tell them what we're going to do. The map on the bottom left is the National EAMLS inventory. This is maintained by the Office of Surface Mining Reclamation Enforcement. And you can kind of see Indiana's arm of sites kind of coming up the eastern side of the Illinois Basin, kind of up toward the sea in Columbus. The map on the right is the same map Tommy just showed you. The difference being the red polygons all over the site, or all over the map, are AML sites. That's Indiana's inventory. So quite a bit of coverage there. These are the problem types from AMLIS that we're allowed to work on. I'm not going to read them all off to you and be a little too much, but on the right side, or the picture on the top right, that's an example of a high wall that we'll typically work on. The top left, that is a shaft next to a stream, and you can see there's acid mine drainage emanating from it. The bottom left photo, that's what we call clogged streamland. That's usually precipitates and stuff from acid mine drainage. So as the metals fall out of the water, they're clogging up the stream, and it just starts to go all over the place and kills vegetation. The kind of middle picture on the right, that is probably our most common site. We get daily calls from the public. I was mowing the yard, there's a big hole in my yard now. I think it's from the mine, and we'll go in and backfill those vertical openings. The picture on the right bottom hand side, that is an old gob pile. That's what we call dangerous pile embankments. Dangerous pile embankments they can vary a little bit. Some of them end up looking closer to just a potential slide. But yeah, it's anything with just sort of severe erosion and can present a safety problem. These problem types are prioritized. We only work on safety problems pretty much at this time because we have too many safety problems in our inventory. We can work on environmental problems, but they have to be tied into safety problems. So vertical opening, this is typically how we'll fix those. You've already seen a picture of what it looks like in somebody's yard. We excavate to the base of the mine, the floor of the mine. We'll deposit riprap in the void. We'll put a little bit bigger aggregate on top of that riprap to prevent the smaller aggregate from going through, and then the rest of it's topped up with soil. The picture on the right bottom is what it looks like when we're done. Our goal is to just put 3 foot of soil over top of it so it can grow vegetation. And we do about 40 to 60 of these a year. It's an example of what we do with high walls. Somebody calls in, says they've got a high wall, kids are jumping off of it or it's presenting a hazard. We'll go in, when I started, we just kind of did a backfill, a 3-to-1 slope off the high wall. Now we're doing full geomorphic reclamation. So that picture on the left is Whitney Pit. It's actually in Sugar Ridge Fish and Wildlife Area, and the picture on the right is what it looks like today. Actually, it's like Tommy's picture. You can kind of see the coal hanging out at the bottom there. And this is what acid mine drainage looks like. This is the Enos gob pile. This was where Alan was at yesterday. And I heard him mention, 40 acres, but I should point out that thing started out, I think, at 118 acres. And we've been doing a remining project out there, and that's what's brought it down to 40 acres. We're actually remining the coal out there. That being said, there is a lot of acid mine drainage coming out of it. You can see that a lot of people call it the oxblood water, on the left side. That's highly acidic water. It's full of iron. The right side, you can see the gob pile in the background, and then you can see our passive treatment system that's constructed just south of it. Don't really have a laser pointer or anything to point out the parts, but yeah, the water's coming into 2. You may see toward the middle left there's 2 ponds with a lot of vegetation growing in them. Those are sulfate reducing bioreactors. So the acid mine drainage goes into those. It's just basically a lot of organic materials, hay, straw, lime, compost. When you take the oxygen out of the water, there's microbes that do some action in there, and then you get alkaline water coming out the other side of that thing. And that red pond that you see toward the left, middle, that is an oxidation pond. And then all the baffles, that's the polishing pond. So all of that iron, aluminum, manganese, and probably some rare earth metals are coming out in that pond, that red pond there.
What kind of amounts do you think? What amounts would that be? Are they just trace amounts, or do you think there's significant amounts in a pond like that?
Well, I don't know enough about it to tell you whether it's significant or not. I have a few slides coming up.
We might ask our next speaker on that.
Yeah, I have a few slides coming up. I see big numbers, and then experts tell me that that's not too good. So,
Okay.
well,
All right. Well, we have about 7 minutes left in your presentation, and then our next speaker will come up. We'll ask her about that.
okay.
Thank you.
Yeah, so this is where we're at today. We've got 16 people in the AML program. Lost one of my engineers last week. Current project funding, we've got a grand total of about $85 million to work on projects. We're turning the wheels on about $79 million worth of projects, and message I can give you there is it's quite the challenge doing it with the same amount of people we've always had. We're going to add $2 million in.
Kit, could you point out that where that money comes from?
Yeah. So there's the fee collection. That's coming from active coal mines. So that's about, what we have to work with now is about $9 million. And then we've got the IIJA money, which is general funds from the federal government, and that's about $76 million. Our current unfunded inventory on projects is $400 million. That's how many projects we've got that people have called in and we've put in the federal inventory.
Wow.
Do you have any concern about the IIJA money continuing, or is that guaranteed?
It is appropriated in the law currently.
It is appropriated? Okay.
Yeah. During the shutdown, OSM is still working because IIJA is already appropriated and in the AML trust fund. Try to make this fast so we can get to the good stuff. This is about how long it takes us to put together a project. You're looking at somewhere between 117 and 197 weeks from the time that somebody calls in and we start turning the wheels to the time that we get permits and are able to administer construction. The permitting environments become pretty rough, as I'm sure the miners here can attest to. When we do a project, we have to go through all the NEPA consultations and everything that a mine would have to do. So this is, I'll try not to, I'm sure Maria's going to cover this, potential sources. On AML projects, we got coal processing waste, acid mine drainage, AMD sludge, and spent substrate. The picture with all the pretty red and orange colors, that is another one of our passive treatment systems. The red ponds on the right are where water is emanating out of the base of a abandoned gob pile. These gob piles are not constructed like permitted gob piles. That's why there's a problem with them. But there's two ponds. The one's really orange and one's not so orange, kind of in the middle of the screen there. Those are anaerobic wetlands. And then there's an oxidation behind there, and that's where you can get an accumulation of these mixed metal oxides. The picture on the right is the purple stuff everywhere is where we've identified impacted streams in the state. This is kind of a list of all of our current passive treatment systems. I think there's 28 on this list, and it's not exhaustive. There's a lot of them that are worth looking at for rare earth elements. This is all of our AML gob and slurry in the inventory. There are these brown polygons all over the map. It does not include permitted or bond release sites. So this is only AML sites. The Secretary of the Interior issued Order 3436 not too long ago. They wanted, basically what they wanted was for, in our side of things, they wanted OSMRE to tell us how we could use our money to get rare earth elements. They came up with this kind of rubric here, and to shorten this up, basically the takeaway is we have to use our money for reclamation. If the primary goal is not reclamation, then we cannot, we can't just use the money to get rare earth elements. But project like if we could haul a gob pile to a rare earth element processor, we could do that.
Sorry, say that one more time.
Yeah. So if we have a gob pile, we could reclaim it by removing it. So if we have a processor, we could remove that. I could pay to truck the material to someone on the premise that it was going to reclaim the site. And on AML, so what you're hoping for here, and the whole idea here why everything's getting pushed toward AML, is the economics don't look good. But if you already have a problem that needs addressed, maybe you can find efficiencies while addressing the issues with that problem. So I think that's what we're all hoping for. That's what I'm praying for. I mean, I want all these liabilities that we've got to turn into resources. I mean, when you go, you go after a resource, you want to get every bit of it out. We've got a lot of resources laying on the ground right now that are actually causing problems. A lot of these gob piles, they just have the program was not very well funded in the past. So the best fix was just this skin of dirt over the gob pile. So it'd grow grass, but at the base of every one of these gob piles that is in like a valley fill, or a lot of times they would excavate the bedrock and then place the gob pile, you're getting acid mine drainage coming out of these things, and they're impacting our waterways. That's why I'm kind of rushing through this thing, but we're building these passive treatment systems to try to lessen the impact on our water resources. Because Southwest, a lot of streams in Southwest Indiana are full of metal. It's just a way to.
And Kit, which ones did you say are in there? I believe you said manganese.
Yeah, so the primary ones that we're dealing with and what's in the National Pollution Discharge Elimination System, that's what we comply with when we're doing these projects. Iron, aluminum, and manganese are like the big three. There's tons of that. I mean, copious amounts of iron, aluminum, and manganese. What co-precipitates with those minerals, though, or metals, is lanthanides and critical minerals. And it turns out they are in these. So we have done remining on gob piles. We have a model for like bidding these projects out for remining. This is a remining project in the picture here. Alan was at it yesterday. We're getting fired back on it now. But like I was talking about, trucking a gob pile, like 2 million yards of gob just to take it a short distance in the state, you're talking about $15 million. It's it's a lot of money just to truck it. I mean, and you've got to have engineering. There has to be a mining plan on the gob pile. You've got to treat water while you're doing it.
Okay. So we're at about time. Do you have just a few more slides, or how far along are we?
I have just a few more slides. I'll go really fast. I think it's what you want to see. We actually test a gob pile for rare earth elements.
Okay, fantastic. And then we'll have our Indiana Geological, and then we have at 11:30 people calling in. So that's what we just don't want to be hold them too late. So go right ahead. Thank you.
Go super fast here. Okay, I want you guys to see this. This is 10 grams of yttrium. right there. This is kind of busy up here. We tested, there's a gob pile, it's a 5 coal gob pile, it's down in Knox County. We had the suite of rare earths and critical minerals ran on it to see if we could get some kind of extra value out of it. Here's the results of some of those tests here. You can see on the bottom, right above where it says direct placement, you've got yttrium. And it's actually, one of the lesser elements in the gob pile. Basically, every cubic yard of coal refuse out there contains about 10 grams of yttrium. That's what's in your hand there. The problem with it is you got to do so much processing to get it out of it. You're talking about processing a ton of material for that 10 grams. So that's where the problems become. One of the interesting things on this one is rubidium. There's $10 billion worth of rubidium in this pile. Getting to that is quite a problem, though. It's in 2 million yards of material. We've also got gallium and germanium, which are big parts of the conversation. Unlike the coal, you still have to do a lot of processing to get to it. So here you've got a picture of a passive treatment system that's on the site, and the numbers for I followed the gallium and germanium with the highlighting here. You can see in the first oxidation pond, there is about $17 million worth of germanium, $18 million worth of gallium. And yeah, it continues. It kind of cuts in half on the next oxidation pond, but that's all being concentrated from a seep. And my slide's being kind of cut off here, but the easiest way to get at the mineral is to get it out of the water. There's about $23 a day of rubidium. That's the biggest mineral in the water. $23 a day coming out of the seep. It would take you 456 trillion days to get the minerals out of the water that are in the gob pile. Yeah, and yeah, I think my time's up, so I'll quit rushing.
Kit, thank you very much. We really appreciate your information here. And certainly that's a big part of identifying, we looked at extraction and the resources we have for extraction, and this is a big part of identifying product. So thank you very much. Really appreciate it. And next we'll have the Indiana Geological and Water Survey, Rare Earth Minerals in Indiana by Dr. Maria Mastoles. And she's our research geologist in the area of energy. Are you taking a break? Are you taking a break?
Can you hear me? Can you hear me? Thank you very much for the opportunity. And as you might have guessed, I was not born in Indiana, but I've been in Indiana. It's this part right there. No, I know. I just put the pointer. But I've been in Indiana for 31 years right now, working on energy-related issues. So over years, I visited all the coal mines probably as they went and came and went and worked with Matt in the past in Farmersburg and sampled lots of mines. So over years at the Indiana Geological Survey, we've done a lot of research on coal and coal waste and also other energy-related issues. But specifically today, I am just going to discuss rare earth elements. Actually, I will start with a brief overview just from very basics, with some reference at the latest part of my presentation to Indiana. So really, let's start from very beginning. So what are the rare earth elements? This is a group of 15 elements that we call otherwise lanthanides from the name of one of the elements. The names of the elements are here, and they have atomic number from 57 for lanthanum to 71 of lutetium. And it also includes scandium and yttrium, these two elements under kind of this general definition of rare earth elements, although these two elements, scandium and yttrium, are not rare elements sensu stricto. Chemically, we divide them into light rare elements and heavy ones. And this is pretty important division because they have different applications. There are also some other classifications of those elements based on their occurrence in their nature and also based on their criticality for our energy and other applications. So are they really, those elements, are they really rare? And on this diagram, I was just showing examples of some other elements, arsenic, nickel, vanadium, zinc, and their concentration in upper continental crust that we often use as a kind of for comparative purpose. So no, they are not rare as it comes to their concentration in nature. But what's rare about them that we rarely find them concentrated locally, concentrated in the amounts that we can actually go and extract them relatively easily. They are just so finely dispersed in most cases. Why, where are we using them today? So this is a diagram that shows our use in the United States in 2024. Most of rare elements go into magnets, 29%, then catalysts, 20%, polishers, 14%, metallurgical, batteries, glass, and others. This is the composite, this is their application, and these elements are so important to modern technologies. And on this busy slide, you see a lot of gadgets and a lot of applications. Then we have to use rare earth elements starting from clean technologies, satellite communication, electric cars, medical equipment, or to fluorescent lamps and hard drives and color TVs. So it's really hard to imagine any kind of further development, technological improvements or advancements without availability and access to those elements. So that's why this access is a very important thing. So what are those properties? Why are they so magically important for us? Physically, they have their appearance. It's usually gray, shiny metals. They rarely occur in, as I said, in those quantities that we can see them. Often they occur as oxides because they readily form compounds with oxygen. But one of the important chemical characteristics is that they have dominantly +3 oxidation state. What it means that atom lost 3 electrons, giving them a net positive charge +3. Why is it important? It's important because as such, they can associate with other elements that have the same oxidation state. And one of those elements is aluminum. And over again, we've demonstrated in our research that there is a correlation between aluminum content and rare element content. So aluminum that we can easily measure and we have lots of information about, we can use as a proxy to identify sweet spots for those rare earth elements. But what are the unique properties that they have? I put 4 here on this slide. First is their unique magmatic behavior. They have unpaired electrons in 4f electron orbitals that are shielded from outside electrons by outer electrons. And that creates a very strong magnetic moment that kind of resistant to any external influences. As a result, they are consistently magnetic. So that's why we can use them in magnets, in permanent magnets. Another property, catalytic property, also owing due their electron structure, but also they have high surface area, they have redox potential, and then they have luminescent properties. They emit light when stimulated by energy sources or electric fields. And each element emits different light. So we really can use them in LED and all kind of illumination. And they have high melting points, which make them also very stable. So now, where do they occur? Where can we go to find them? Well, our rare earth elements occur in rocks. So I guess it's good to be a geologist, right, to study rocks these days. And in this slide, I put a kind of comparison of what are the main hosts of rare earth elements. The most important are carbonatites. Carbonatites, these are igneous rocks rich in carbonate minerals. So rare elements just come from original magma, and their concentration is related to partitioning of element partitioning processes. Then alkaline igneous rocks, which, for example, peridotite, also important host. And then we have iron oxide copper gold deposits, then placer deposits, and some other deposits. So these are those kind of traditional sources that we know most about. And then we also have mines that we can extract those rare elements from. Again, traditional, those magmatic, most of them are magmatic rocks. Let's look at world reserves. And we, based on estimates, we think that there are 120 million metric tons of these elements available. And when we look at distribution between countries, China dominates. And then we go Vietnam, Brazil, Russia, South Africa, India, Australia, Greenland. And here, if we can really see it, it's United States with between 1 million, 2 million metric tons. Again, this is the estimate of those traditional sources that we know most, and not including additional sources that we really kind of start to look into over the last decade. Well, let's look at production over last from 1985 to 2020 something. So, and you've seen this in similar diagrams probably many times. So the red area, this is China production. And then when you look at this blue thing, this is production of the United States. So you can see, and production of the United States, again, from traditional sources. That comes from just one mine in the Mountain Pass mine in California. So what you see from this diagram, there are periods here that there was no production whatsoever, and that was because the mine was shut down because of environmental concerns, and also because of Chinese competition. So looking at that diagram and thinking how important is supply and access to those rare elements, you can see how really important that we look into some other sources and we really identify them and try to make use of them, what we have here. One just moment, let's look at a little moment about this Mountain Pass mine in California. I wanted to show you. This is an open cast mine here. This is the largest and the only producing rare earth element mine in the United States. It was discovered in 1949 while prospecting for uranium, and it sits on Precambrian carbonatite formation. In the previous slide, I was showing the carbonatites, that's the main source. So that's what they have in California at that mine. As of 2022, work was done to restore processing capabilities, both for light and heavy rare earth elements. And in 2025, the mine was reported as operating, and their company, MP Minerals, they got a huge support from the Department of Defense and also loans and long-term guarantees. So hopefully the mine will be operational for years to come. Let's look a little closer again at this production and consumption in the United States of these elements. So in terms of production, world production about 390,000 metric tons. This is China production. So you see that definitely dominates. This is we saw on the previous diagram. US production from or this traditional source, not from like recycling, is 1,300 tons right now. And I just put here numbers from 2020, 0, 2021, 120, 2022, 95, 250, 1,300. Very little production really of those metals. So now let's look at consumption. And again, these numbers are difficult to find. These numbers, there are different numbers when you look at different sources. So I tried to use the numbers from federal, from USGS and from DOE. So US consumption, 6,000 in 2020 to 10,000 in 2022. Right now in 2024, 2025, we sit at estimates are between 8,000 to 6,000 metric tons, with production 1,300. So you see that as a result, we obviously import all of those metals. On this diagram, I just only wanted to show a range of prices. Prices of rare elements change. They change pretty much on daily basis. And this is one of the problems that is difficult to kind of handle with prices that are dictated by China and also by political situation. It's very difficult, and they can change not 10%, by 500% within short period of time. So it's really hard to evaluate the values of. One thing that I wanted to show here also, this is like diagram of importance of rare elements as well as other critical minerals to our energy security. Comparison 2005 to right now 2025 versus up to 2030, and our rare elements and also other critical minerals such as gallium, such as magnesium, such as lithium, such as graphite. These are very important elements. And when we talk about resources later and work on them, we also need to think about those other, going beyond rare elements and think about those other critical minerals, because we will be even at a bigger crunch here, with high release supply risk to what we need to have in order to develop our technologies.
Excuse me, Dr. Metelers, can you go back to that last slide and identify which of those are found in Indiana, if you can?
Right. So when you look at this, dysprosium, iridium, neodymium, praseodymium, terbium, these are rare earth elements that we do have in pretty much in fly ash, we do have in coal reject, we do have in coal, we do have them. Often they could be associated with gallium, it could be associated with germanium, sometimes we also have lithium, all these things, and in the report that we are preparing for you, all these things will be discussed and kind of with reference to possible extraction or co-extraction. Okay, so kind of to summarize about those traditional sources of rare earth elements. So traditional sources, so that's alkaline igneous complexes or carbonate-rich igneous rocks that crystallize at high temperature deep within the air, the earth, and they often have several percentage of rare elements by weight. This is what we would love to have. But and they can occur in specific minerals, basanite, monazite, and these are kind of the largest mines those in those traditional magmatic rocks. And that's also our mountain pass in California. Now, as these conventional ore deposits become depleted in response to large demand, the possibility of recovering rare earth elements and other critical elements from other sources, such as sedimentary rocks and carbon-based materials, become pretty much exciting, but also a necessary direction. But we have to remember, all of those non-traditional low-grade REE resources, usually less than 1,000 parts per million, and often much less than that. So let's just think a little bit about Indiana perspective and critical minerals. The first thing that I want to say, Indiana does not have traditional sources of rare earth elements, but we do have other rare elements and critical mineral bearing materials. And these are our sedimentary rocks, and these are our coal waste. And over years, over a decade or a little bit more, we've been supported at Indiana Geological and Water Survey from federal sources to study precisely those formations. So we looked at phosphorites or Ordovician and Silurian. We looked at Pennsylvanian paleosols. We looked at Devonian and Pennsylvanian shales. And this, we were supported by USGS. And then we look at coal and coal combustion byproducts. And we were supported by DOE. And as a result of that, we generated a lot of data, and even before. So, and again, we were discussing this and evaluating that in the report that will be available pretty soon. And talking about those unconventional resources, so as I said, coal-based materials present a special opportunities. And I like to show this diagram that shows a progression from coal reserves through coal mining, through coal separation, coal preparation, and then through power generation systems. And at every point of these activities, we do have rare element recoveries opportunities. We can look at them. We do have them. It's in coal mines and around coal mines. We do have them in around coal preparation plants as gulps and as slurry ponds and as acid mine drainage, as Kit was showing. And then we do have a lot of coal ash that is available and sitting in coal ash impoundments. So there are those opportunities present. But while I'm saying that, we have to remember that this is low-grade materials, and recovery from these low-grade materials will be difficult, is difficult, and it will be costly. And why it's so difficult? As I said at the beginning, those rare elements are very dispersed in rocks. So that's one problem. But the other thing is that it's also important, and we need to understand very well where they sit. So in what associations, in what mineral associations, because if we understand that, we can kind of plan our recovery processes to maximize or to optimize those processes. And here's let's think a little bit about, for example, coal ash that we have so plentiful in Indiana. Those rare earth elements are dispersed at nanoscale, very fine at a nanoscale. And it happens that they are also dominantly associated with this glass material. It's glassy material. We know when coal goes through very high temperature, elements, minerals melt. And then this melt, it forms this very strong aluminum silicates that it's in glass kind of association. And it's very difficult to touch with any acid. So a lot of very strong acids are needed to do that. So it's not only this association of great dispersion, but also just that they are dominantly sit, at least in coal ash, in that very strong, very kind of rigid, glassy component. So yes, so recovery, we need to be prepared for that, and we need to make sure that we do all what's needed in order to understand best where they sit and what and kind of gear that towards what we need to use so that recovery is as least costly possible. But it's possible over various lab experiments as well as pilot studies demonstrated that extraction from those coal-based materials is possible, but it's a complex process. So here we start with ash, we have to go through physical beneficiation first, hoping to get some pre-concentration. Pre-concentration is very important with those very finely dispersed materials. Then we have to go through a metallurgical treatment, which usually combines heat plus acid. Then we have to go through acid solution, very strong acids. Then eventually we go into a separation process that hopefully at the end we will have a high purity rare earth elements, a concentrate. So that's pretty much what I wanted to mention. Only in Indiana, we will have lots of that discussed in the report that we are putting together. And I just have a few of those conclusions, and those conclusions are not related to actually my presentation, but conclusions in general for Indiana. And what I say here, that Indiana, with its long history of coal mining and energy production, holds significant potential to reduce the dependence by recovering rare earth elements and critical minerals from unconventional sources such as coal refuse, coal ash, acid mine drainage, paleosols, and metalliferous shales. All these resources are, however, of low grade, and although recovery methods are technically feasible, they will vary in cost and complexity. Environmental and regulatory framework are both a constraint and opportunities. Indiana has already rules for coal refuse reclamation and coal ash disposal, but modifications will be needed to support safe and beneficial use of mineral recovery. At the same time, mineral recovery could mitigate legacy risk, reducing waste volumes. And state and federal policies need to be aligned to encourage investment while maintaining strong environment safeguards. With targeted support, we believe Indiana could move from being a legacy coal producer to a leader in securing critical minerals for the U.S. economy. And really what I also wanted to leave you with a message that comes from this slide. In this show, net import reliance and percentage of consumption in the United States. So as you can see, we have lots of minerals that we rely 100% on import, and a lot of them, large percentage on import. And these are gallium, it's germanium, it's graphite, it's rare earths, it's yttrium, and many other critical minerals. So when we go and think about our resource in Indiana, we should think complexly about rare elements plus some other critical elements that, because there may be this co-occurrence, a co-production or co-recovery may influence and reduce the cost of the total recovery. And here is just to show how beautiful all these materials look under microscope. Thank you.
Thank you so much, Doctor. That was a great presentation and very well done. We learned a lot. I also look at this as a great look at product development. And I also want to make the note, last night I was fortunate to be invited to speak to the geologists of Indiana, two of the professional organizations. And also we've gotten to know your office. Our office has gotten to know your office by your director, Todd Thompson, and also, I wanted to make note for the committee, for the council here, that the geology industry seems to be declining and does not have the financial support, does not have the interest that it once had. And I think that that's something that we should be paying attention to as a council for our state. It's something we need to be raising awareness of for our country. It's extremely important when we think of product development in terms of rare earth elements and critical material. And it's extremely important when you look at the presentation from Sunrise Coal, how important that is to have a geologist go ahead of the mining, that if they didn't go ahead and know that there's water there before they went in, the miners could have been drowned before they went in there. And so not just for product development, for safety reasons, and for many other reasons, this is a very important study that our country needs to be able to continue to cultivate with young people. So I think that's something that we should consider as perhaps a subcommittee for this council. But thank you very much, Doctor. We look forward to keeping you as part of our outreach, and we'll certainly do that through Todd's council here. Moving on to our next presenters. Fortunate to have, hopefully on the line, Ned Mamula. Ned is the director of the United States Geological Survey. He is recently Senate confirmed in this position, and he's a good friend of mine. He has worked in geology all over the world, has a background of working at the U.S. Department of Energy, working in various states, working as I said, around the world. Also with Ned is Lanny Erdos. He is the Director of Service Mine and Reclamation Enforcement, an office that we've talked about quite a bit here in this forum this morning. And it's really a great honor to have both of you gentlemen here joining us from Washington, D.C. to help us kick off the Indiana Rare Earth Element Recovery Council. So Ned and Lanny, thank you so much for being here. I want to let you know that our council is here made up of state leaders, both internal from the state government as well as leaders from industry, and also people who have been presenting to us this morning. We have had presenters from industry giving us a history of mining in Indiana, the Department of Natural Resources presenting about abandoned land mines and what's present there in terms of different kinds of materials and critical material, rare earths, as well as the Indiana Geological and Water Survey that just finished their presentation. And now we look forward to hearing from you about what's important from a federal perspective and perhaps what other states are doing on a similar level. So Ned and Lanny, Director and Director, we'll turn it over to you.
Okay, Susie, thank you very much. And the Rare Earth Recovery Council. I'm Ned Mamula. I'm the director of the U.S. Geological Survey. I was recently sworn in, as was my colleague here to my right, Mr. Lanny Erdos. He was sworn in as the latest director of the OSM, Office of Surface Mining. So the two of us are speaking to you from the Interior Building in Washington, D.C. Sometimes I'm lucky, I get to go out to my home agency in Reston, Virginia. If you haven't been, I invite you to come visit. But for now, we're here, so thank you for the invite. We're each going to talk about the things that you're interested in from our perspective. I hope you don't mind, and I hope it sheds light. First of all, you know, no surprise, the rare earth elements that you hear about on every single news cycle, day in, day out, they're very important to our national security, our economic prosperity, and also our technological leadership ability, okay? Unfortunately, we're having to import all of these from China, and the problem is we actually led the world in the development of the rare earth industry as long ago as the 1880s, if you can believe it. It was in New Jersey. And that industry started to form. It was uniquely American. And some of the offshoots were, the metals that went into, I don't know if you remember Zippo lighters, the Mish metal and all of that formed out of the rare earth industry way back when. And as the years went by, we lost our ability to process and refine rare earth metals. And lo and behold, it was taken over by China, primarily because they worked hard on it. And today they have, you've heard of our national labs, they have actually 6 or 7 national lab equivalents devoted strictly to rare earth metallurgy, rare earth chemistry, rare earth mineralogy, rare earth geology. It's incredible. And I grudgingly admire the way they've attacked that problem. Last week, we finished here our final 2025 critical mineral list, and on it, it was published in the Federal Register. And on that list, and for the past year or two, are listed the 15 rare earth metals individually. There was a time when USGS, who put out this list, puts the list out, listed rare earth, which is nothing. I mean, it's a descriptor. It's not a thing. It's just a descriptor. And I chided them. I said, guys, these 15 each have a market, each have a use, each have a refining method and so forth. Each one needs to be called out. And so our list went from 35 overnight to 50. And today it's 60. So in a sense, rare earth elements, and I like to just, in my shorthand, rare earth metals, because that's what we're interested in, have become, in a sense, the canary in the coal mine, because what we are experiencing through our absolute need to import them from another country, in this case, sort of an adversary, is happening now with other critical minerals such as gallium, germanium, and so forth. All right, so they're marching right down through the list of critical minerals, and we are almost powerless to stop it. Okay, what do we do about it? There's been a big upswing in research to look at how we're handling the rare earth issue, primarily from the processing standpoint. Let me explain. As with most other critical minerals, the rare earth issue is absolutely not a resource issue. There's at least 8 deposit types of rare earth elements, and in this case would be rare earth element bearing minerals in the ground in our country and in Canada, different ore types, ore deposit types, 8 of them. So there's plenty of rare earth material in the United States. I've heard people say, wow, if we discover one more mine, we'll have the problem licked. No. What we don't know how to do is take that material and process it. The mine in California was sending their ore to China, and then we were buying it back. Makes no sense. So there's now an effort. And by the way, MP Materials, to their credit, has set up a processing facility in Fort Worth. There's one going in Stillwater, Oklahoma. And we're on the road to getting processing back in our country. Processing means producing concentrates, and from those you're going to do separation of the metals, separation of the oxides, and then processing of the metals. And then the metals are the thing eventually used to make magnets. Then there's a divide. You have light rare earth and heavy rare earth. People say, great, we have plenty of rare earth. Well, they're talking about the light rare earth that are needed for blenders and maybe computers and maybe a kid's toy, things of this sort. What we do not have access to right now are the heavy rare earth elements, which are needed for high operating temperature applications like disc brake calipers, jet fighters, aircraft carriers, cruise missile launching destroyers, other military applications, and so forth, and even some medical applications. So it is the heavy rare earth element applications that we're sorely lacking. And so we are, do we have heavy rare earth in this country? Yes, we do. There are a couple deposits where they've been identified, and we're working on those now. But as it stands, China has about 70% of the world's production, 90% of the world's processing of rare earth metals and the compounds, but they have 100% of the heavy rare earth processing. 100%. If it could go to 101, it would be 101. Believe me, they've got it locked up. So this is where we are, and it's a game of, it's a race against time to bring American ingenuity and innovation into the equation where we can set up and process these metals, these minerals, get the oxides, and from that make the metals that are necessary to get injected into the supply chain and moving down into the manufacturing. Unlike energy, think about it this way, unlike energy, which we all know America is energy dominant, and it feels good to say that and live that, our minerals, especially our critical mineral output, is nowhere near dominant. It's nowhere near even independent. It is sorely lacking, but you know, nothing like a challenge for Americans to step up. And so I'm glad and happy to be part of this. And, you know, and I can't wait for progress. I think we're on the cusp of making progress, and I'm happy to hear that Indiana is kind of leading the way. You guys are leading the states in doing these things, and that's great. And I'm going to turn it over to my colleague here, Lanny Erdos. But before I do, let me just say this. You know, the things that were left behind on the ground by our forefathers, whether they're metal mine dumps or they're tailings, sometimes called, or coal refuse or coal waste, or whatever you want to call those piles on the surface that are left by our forefathers who were mining but didn't have the technology to squeeze everything out of the material. Now, lo and behold, technology is allowing us to go back and get materials from that waste, so-called waste. Those things have been referred to as byproducts. And I'd like to leave you with a thought here. That term byproduct has a connotation of, you know, something that's wasteful and not wanted. In fact, in the rare earth mining industry, interestingly enough, some of the lightest ones like lanthanum and cerium, you have to pay money to get rid of that. It's like, no one wants that anymore. You can't even get rid of it. You have to pay. But for the things that are valuable in the tailings or metal mine dumps left behind that we can get to because of technology, we should be calling them co-products. And I refer to that as co-production. If I'm a banker and you come to me for a loan and you say, hey, I'd like to have a loan to mine some copper. Oh, okay, here's your loan. Thank you. I go on and I produce copper, I produce rare earth, I produce rhenium and maybe cobalt, and I report back to you. I'm going to be in love with you. You're going to be a great customer because you've achieved, you know, through co-production. So I've come to call these things now, for people who may be anti-mining, I just say, listen, relax. There are ore deposits on the surface. Look at it that way, okay? So everybody wins. The environment gets cleaned up. The material goes away, not before it's taken, reprocessed for anything of value in it. Then it can be used in reclamation, which my colleague will mention in a minute. So in summary, I think the more wisely we handle our mineral wealth, and it is wealth, with our country is so rich you cannot believe it, the more wisely we understand it and handle it and use it, the better off we'll be as a country, because believe me, energy and minerals are really the lifeblood in our national veins. I know everything is important, but those two things, without that, we sorely have a problem. So with that, I'm going to introduce Lanny Erdos. He's the director of OSM.
Thanks, Ed. I really appreciate it. I appreciate the opportunity to be here as well. I'm very excited to see what this council in Indiana is doing, and I think we're kind of running a parallel path. We're looking at very similar things here at the Department of Interior, particularly OSM, in regard to coal refuse sites and coal waste. A little background information I think is appropriate for me. I was the director under Trump 1 as well for the last year and a half. And prior to that, I worked at the Ohio Department of Natural Resources. And I managed our coal and industrial mineral programs, as well as our BMI land program, which many of you are familiar with, as well as a mine safety program. And sandwiched in between that, I worked for a co-operator where we had large operations in Wyoming and Powder River Basin, as well as met coal in West Virginia, and liabilities in Kentucky and Virginia and Alabama. And my job there was president of the Reclamation Company and vice president for environmental compliance across all the various companies associated with the parent company. So I have a little background in regard to coal refuse, not only from the state side and the federal side, but also the industry side. And there's certainly many coal refuse piles out there, including in Indiana, but in Appalachia, there are a number of those, and I've seen a number of those coal refuse piles. One of the things that we had done at our company was have one or two of those tested for critical minerals, as well as acid mine drainage discharge for a couple sites. And I think that's one of the things that we really need to concentrate on is the testing. As far as the mapping is concerned, I know that Ned's working on that, and we're doing a little work as well at OSM in regard to mapping some of these sites. And there's tremendous potential out there. The potential is just tremendous. But the numbers are tough. The economic numbers are the issue, and we have to work through that. So what we're doing at OSM, we're looking at all these coal refuse sites really across the country. And what we are trying to do based on executive orders and secretarial orders in regard to critical minerals and coal mine waste is come up with incentives for the industries to actually consider mining these coal refuse sites for critical minerals. So the question is, how do we go about doing that? And, it's a difficult question. Title IV, which is AML, we are looking at incentives at OSM, and we've committed to the secretary to come up with recommendations by the end of the year to mine those sites for critical minerals. And, what does that look like? And we don't have the answer yet. I think we're going down parallel paths, which that's why I'm excited to be here. I'm super happy that Ned asked me to attend. What does that look like in Title IV at the end of the day? Of course, we're not going to require a permit. There'll be no permit for Title IV mining. Do you reclaim just part of it or all of it? Do you have to remediate the entire site? These are rhetorical questions. We don't know the answer to that yet, but we're working on coming up with an answer because there's tremendous potential out there. In Title V, which is the regulatory side, what does that look like at the end of the day? And that's really a heavy lift to get around SMACRA, Surface Mining Control and Reclamation Act, and I understand that. But I think we have to take a close look at Title V. There are a number of coal refuse sites out there, coal waste sites under Title V that potentially has tremendous potential in regard to critical minerals. So again, what does that look like under Title V? And I'm willing to do almost anything within the boundaries of SMACRA to allow for critical mineral mining on Title V sites. We're going to work on that. We're going to continue to work on that. And we're working with our state partners. The Interstate Mining Compact Commission, which is a group of 24 states, coal, AML programs, as well as hard rock. They had their mid-year meeting here in DC last week on Monday and Tuesday, and I spoke at that meeting and spent 2 days with those folks. And I know many of those folks because I represented Ohio for about a decade on the IMCC, and we talked about critical minerals. And we asked for input from the states, and I hope to get that in the next couple of weeks. This is what we're trying to do at OSM. This is what we're trying to do at the federal level. This is what's happening in the Department of Energy. And again, I think as someone, we need to look at the Department of Energy as far as partnership as well. And we need feedback from the states. What can you do? What are your thoughts relative to incentives to mine these coal refuse sites and coal waste sites for critical minerals? And what does that look like? So we're hoping to get some feedback from those folks in the next couple of weeks. I also intend to engage industry across the country. What interest do you have? And this is what we can do for you to incentivize you to mine these sites. So I'm very excited about talking with the industry and see if we can come up with a plan that will make these sites attractive for those folks. And again, I'm not naive. I understand it's a heavy lift, and I understand the economics associated with it. So we've got to look at how we make it attractive, and those folks can actually make money doing it. So again, we're just starting. We've only taken one step, and we've got many steps to take here at OSM at the federal level. But we're going to be looking for help from the states, and I think this group is a great group. Again, I'm looking at, and I spoke with them about this morning. We really needed OSM to partner with you. I read the governor's executive order, and the things that you're doing are the same things that we would like to do. So I think it'd be a great partnership, a state and federal partnership as we move forward. So I'm looking forward to the potential of that happening as well. But again, at OSM, we're really just getting started on this. There are many, many coal refuge sites out there. They all have tremendous potential. We're going to need state's help. We're going to need the industry's help. I think we need to work with DOE. They have done some work in the past, and I think primarily it's fly ash and slag, not so much coal refuse. But that's something certainly we can talk to those folks about as well. But I'm excited to be here today. I'm excited to see what you come up with as well, as far as these coal refuge sites and the potential to mine critical minerals. So excited to be here. Looking forward to working with you in the future, and I think together we can make a difference. Thank you.
Okay. And with that, I'll wrap it up with a few comments, folks. Susie, again, thank you for the invite. Look, Lanny and I, Director Erdos and I are on the ground kind of guys. We're not academicians. We really are with you in your efforts here. And so as we leave you here, remember that whole idea of co-production. That's really the way we want to think. We're going to change our thinking about a pile of waste. Pockets of waste. No, there's products in there. We got to find a way to get them out. And also ore deposits on the surface sort of calms down people who are anti-mining. It's to say, oh, okay, well, we'll go after the. And I take you to that southeast corner of Pennsylvania. Those metal mine dumps there. I think you'll enjoy that. Some of them, the U.S. Steel, J&L Steel, the Grace Mine, they dump those things there years and years ago. Some of them are at 1+2%. They're at ore grade. They're actually above today's ore grade. So I'm saying there's great promise in this, whether it's metal, bearing minerals, coal refuse. And by the way, folks, more and more work being done at universities, to their credit, and others, on the coal underclay. And I've heard people say, yeah, we strip the coal, and I'm from Pennsylvania. Lanny has ties in Ohio. Strip the coal and we're done. And I said, what about the clay underneath? It's loaded with critical minerals. Oh, no, we take that down and we have that empty hull capability, and we take it to refractory and make pottery out of it. Oh, geez. There's value there. There's value. And the rare earths aren't so much in the coal as maybe they are in the underclay. So it is an exciting time to be looking at all the things in our country and to figure out the way. That's one thing. Maybe China is, leading the way now, but with American innovation, we're going to come up with some really nifty things. And again, if we can do it with rare earth, think of all of the jump aheads we'll have with the other critical minerals on the list. And with that, Susie, thank you. Did we answer the mail for you, Susie?
Absolutely. More than delivered. Thank you so much. If you could hang for just a moment with us, I'd like to open it up to the council and see if anybody has any questions for the two directors while they're here on the line. Yes, Ben Reisman.
Yeah, I was just going to make a comment. I appreciate the comments from Ned and the colleague. I think it's important to think about technology. As I was sitting listening in throughout the morning here, it's exciting for me to hear about. Hopefully everybody, I caught the tagline again. I'm a technology guy. Sometimes people are like, technology, what's that? But, hearing, from Tommy even this morning, the impact of technology on coal mining over all those years and what it brought about on efficiencies and reclaim and opportunity to where with the amount of coal that we get out today, the limited amount of, wrong phrase, the efficient amount of people that we can do today and the efficiency that they supply power with is attributed to obviously the human capital, but also technology. And so, as we think about these resources that are on the ground, it's almost, in my mind, it's almost a rethink of what, of coal mining of yesteryear is. As they started to lean into technology and opportunity, I'm sure even at that time, folks may have not seen some of the value or may have thought it was really expensive, or the amount of people, or the amount of equipment, the amount of capital and resources that this takes. But they recognize the value of that, and we've managed to extract and make that value more efficient over all these years. So I appreciate the comments, and I think that's awesome to think about in the United States. Because having traveled, so spent time in the mine, underground, above ground, processing centers overseas, China, South America, all of our, I'll say our leading countries today, definitely China being one of those, over the last about 18 years, a ton of time there looking at their capabilities. Again, it's been brought about by technology. Yes, they are doing some old techniques in some cases, but a lot of it has been refined techniques through the entire processes, from extraction to concentration to how they use those materials today. So I'm excited to see what we can do in Indiana as thought leaders by using our innovative universities, our geologists, our technology people, folks here in the United States, where we can lean in and use technology to hopefully extract those, what were low value or high risk, if you will, to create high value and high efficiency like we did with coal.
Thank you, Ben.
Great.
Yes, Michael Woods.
Hi, gentlemen. Good morning, and thank you for taking the time. I've got a question for you for the state in terms of attracting corporations to come here to work on this problem that we have in the United States. Huge amount of competition for recycling, for taking these rare earths into black mass, for initial production of black mass to get into batteries, repurposing and recycling of those after 8 or 10 years of their first life. What can Indiana do in partnership with the federal government to attract companies here to do that good work alongside everything going on with the coal initiative for this council? How can we attract companies with your partnership from Nevada, Missouri, Kentucky, Michigan, you name it, other states that are doing the same thing, trying to do the same thing? And like you said earlier, it's a race. How do we win the race?
Yeah, so that's the $1 million question. So we're working on that here at OSM. How do we incentivize companies to come in and do this work across the country, including Indiana? There are many opportunities in Kentucky and West Virginia as well. So we don't have the answer to that today, but we're working on coming up with an answer. I think there has to be an incentive. We have to make it attractive. And what does that look like at the end of the day? That's the $1 million question we're trying to come up with right now. And we can certainly use your help in coming up with that.
You mentioned a coalition earlier. I'm curious, so many states are trying to do the same thing, and rather than fighting for the same dollars, why don't we, as mutual states, work together to access the same dollars to move faster together rather than individually? Is that possible?
I think it's very possible. I think it's something that we certainly have to look at doing. And, again, I think this organization, this council that you put together in Indiana, is maybe the first step in making that happen. I'm excited about partnering with you to come up with the answers that we're looking for. But yes, if we can get a group together, I think that's very, very important. As I said, I met with the IMCC folks, so they're really a group there at 24 states and are already together. They're already working on some input for us here at the federal level, and including Indiana, on what they think might be important in making those sites attractive for companies to come in and actually mine those sites. So we're looking for some of that input over the next couple of weeks. We have some ideas as well, but at the end of the day, we're all going to get together and come up with, we hope, not necessarily a solution, but a path forward on how we make this happen. And we really have to. It's a national, as Ted said, it's a national security issue, and it's going to be that. And it's not going to wait tomorrow, next week, or next year. And it is a heavy lift. I understand the heavy lift. I'm not naive. But at the end of the day, we have to make it happen.
Yeah.
There is no plan B. It has to happen.
Totally. I mean, when you've got 90% of the refining happening, 70% of the production to one of our biggest, competitors and
not exactly big friends right now to the United States. It makes a lot more sense that so many states should be winning, not just one. And the more that they can do together and collectively, we need every ounce of these tons of production that we can get.
Yeah, and ladies and gentlemen, don't forget our environmental brethren. If I've ever seen an opportunity for industry and environment to work together, this is it. I mean, I can't think of a better scenario. Hey, there's an ugly pile there. Oh, okay, we're going to take it away. Oh, thank you. Wow, how can I support you in the future? It's almost like it fell out of the sky. Good, okay? Where the thing goes away, it has value. The land is restored, and all of a sudden, you don't need to sink a shaft. You need a couple front end loaders and some trucks. This is a win, and we need to hunker down now and get a solution. It's so almost too simple in a way. I'm being naive, but if we get regulations out of the way and get to work, Indiana, you guys are really poised. Your neighbors in Ohio, they could learn from you. And if you cross over into West Virginia, my good colleague Jessica Moore, state geologist, you look her up. Her and her folks have written extensively on underclays beneath the coal seam in each case, and all of the wealth contained in those. So, FYI. So, okay.
Any other questions?
Thank you, Susie.
Okay, well, we'll let you go, but keep in mind, we'd like to be your test state, a beta, and definitely your partner here. So we'll keep you updated on our activities. And thank you, gentlemen, for your help here. It was outstanding.
Thanks. Thank you. Appreciate it.
All right, have a great afternoon.
Good work.
Thank you.
Bye.
Bye-bye. Okay, well, that concludes all our presentations for today. It's time for us to have discussion. First of all, I want to just remind everyone that our end game is to have a report for the governor December 31st, 2026. So we have some time to think about this. We have some time to germinate on it, but also that time will be short. And I hope that we'll have a lot of action and activity between now and the time that we actually have our final report. I would imagine our final report will be something akin to a business plan, but a business plan that's already up and running. And so that is the vision that I hope for. I'd like to open the floor for the council to talk about what your vision is, questions, comments, thoughts from today. Yes, sir.
Thank you, Secretary. Appreciate it. I think as we think about what's going in that report, I think ultimately Michael's point is the right one, and I'm glad he brought it up. It would be, I think, critical to have an understanding of what the landscape, who does this work. Given what we heard, how difficult it is to and expensive it is to extract or to process or to do this work, who's here that can do it? What's in the pipeline? Have we been approached? This is an IEDC question, right? But have we had any interest or nibbles on this over the last, couple of years? Why or why not? I think we've got a tax environment that's competitive, and we've seen that when we invest dollars in economic development, it works. We attract investment. So are those investments we're going to continue to make? Should we be continuing to make? I understand the point. I think it's well taken about looking at how states bundle this together. But the reality is that anybody who does economic development knows that you're in competition with these states. And so if we want them here and they don't already exist here, then what are we doing to go get them? And if they do exist here, what are we doing to ensure that they've got the tools necessary and the investments necessary to do the work? So as we think about what goes into this at the end of the day, the end product, I think 2026 is probably too late for this particular piece, right? Because that competition is probably happening right now. But I think certainly this is a critical component of it. And Michael, I'm glad you brought it up.
I guess, Susie, Secretary Jaworski, I should say, been too close for too long. It's Susie, so I'm Matt. But anyway, I guess one thing that I think is very, very important here as we go forward, we need to identify and get some of the end users in here. Who wants this? Who is out there screaming for it? Who doesn't want to import it? I think, as with anyone, we're all coal miners, or a lot of us are coal miners in here. There has to be an end user. Who wants my product? And we need to find them end users get their interest. This is a new and growing industry, and to not engage the end user would be the wrong answer. We have to identify who that is, where the product would go to, and get information from them on what are they looking for. You know, what's number one on that chart? There's a lot of minerals there I didn't even know about. What's number one on that chart, and find out where we can go with it. But I think engaging some end users here would be a very important piece of it.
I'll offer up.
Oh, yes, go right ahead.
I just
and
think
then
the
Senator
technology
Good.
readiness is fairly low. I think it's an exciting prospect, but I don't think all the technology is there. So it might be useful for us to look into our academic institutions in the state and see what might exist and what they need maybe to accelerate that. I think technology being low and costs being exceptionally high, feels like a hard place for the private sector to jump in immediately.
Thank you. Senator, and then Doctor.
Yeah, I guess to that point, there is definitely a sense of urgency for national security. What would be helpful is in the part about getting the idea of the landscape, a lot of this is driven at the federal level, and to maybe be better informed, the federal jurisdiction versus what we can do as a state.
Mm-hmm.
And if we could have almost like a side-by-side of both the opportunities, what are the regulations, what are sort of the roadblocks, that would probably be helpful as we produce this report.
Great point. Thank you very much. Doctor?
Yeah, just wanted to add, when you were writing that report, I was thinking about the same question, and I was thinking that it would be a good idea to put a list of kind of projects, relevant projects that we have currently going in the United States, and who funds them. And so as appendix, we put a couple of tables there that we have, like current projects, sources of funding, possible people to contact who are interested in, because, you know, we go around, we talk to various people as well. And another appendix, I put like the entities in Indiana who have something to do with rare earth elements, with their contacts, emails. Some of them I contacted just to make sure that they exist. So it's just kind of them to, I think it could be useful to kind of look at them and to know who works on what.
Mm-hmm.
And another thing that I do want to say that it's really good time probably to make contacts with major industries, because I've had several meetings with Peabody from the headquarters in St. Louis that contacted me and said, we want to work on that. This is the time.
Good.
So I think we need to capitalize on that and really reach out to those companies. Then National Labs, they contact me pretty much on a daily basis, and with projects and proposals that they are working on extraction, and asking what would be most important so that we can make the overall recovery process the less expensive, you know, it's less expensive. And one of the processes, I mean, if we deal with those very low grade materials, it's very important to pre-concentrate them. And from 500 ppm, we want to pre-concentrate them to 2%. That would be a huge gain, but it's so difficult to do that. So how can we improve those pre-concentration processes based on gravity, magnetics, flotation, whatever, grain size? We have a lot to go here, but I think we can make major improvement. And with experience that we have in preparation plants, various in Indiana, and working with coal companies, I think we can really, it's time for us to really reach out if we want to make it work. We all have to start working together. It's not going to be easy. It's going to be very, very difficult, and a lot of money will need to be put, but eventually we need to prove and we need to establish some facility potentially that proves that we can do that technologically, we can do that safely, and we can, but only then we will understand what are the environmental implications. Only if we have a facility that really provides us with a lot of material and a lot of to analyze, so and put a good model together. So, but I think it's a great time, and I'm just so excited that I'm not retired.
Thank you so much. Yes, sir. And then,
Hey, could you go to the microphone and turn it on? Because people at home just get silence from us. Thank you.
Yeah, well, I just want to tie right into what Maria's saying there. There's levels of concentration, and from my seat where I'm looking at it now, like I could be pre-concentrating rare earths on a site right now if I had funding that was eligible for that. But you're talking about like a $600,000 initial investment and then $137,000 a year to run a facility that would produce maybe $10,000 worth of elements if you could find the buyer. So the processing, like we still have some fine tuning to figure out where it's at and where it's most concentrated. But where we're really lacking is in like industrial scale processing and the levels of processing and where that can go. Like mixed rare earth oxide seems to be where it would, where you would want to get to and then send to a specialized processing facility. So
we need to show that we can do it, and if we show it, then obviously more industry will come to us and will be interested in being part of that.
thank you.
I
Yes, Michael.
wonder as we're building this plan for the end of next year, I'd probably caution one thing and then encourage another. So when you're going down too many parallel paths, human beings just don't remember more than just 2 or 3 things. Businesses can't compete. They get too diluted when they're trying to do 4 or 5 things at the same time. So if we can probably concentrate on fewer things to get quicker wins, I think that's what the Indiana state would like. As well, I wonder and encourage if can we combine in some way with other initiatives that are already going that might need a little lift from time to time? There's so many different initiatives in Indiana, such as the Silicon Crossroads Hub, as well as SK Hynix coming in, both of those going towards advanced electronics. Advanced electronics is a huge consumer of rare earths. Right? One of the biggest out there. If we could find a way, and all the coal talk right now is, in my opinion, as a simple finance guy, essentially that's recycling, right? For additional materials. Recycling materials that can help in existing initiatives such as advanced electronics enhancements in the state might be a good correlation to bring those two together. This initiative complementing that initiative and vice versa.
Great point. Thank you. Any other comments or questions from the council?
Susie, I just had one. I was
Please.
I think in an emerging area like this, two danger zones are 1, too many regulators, and 2, too many lawyers. But I was just going to flag, I think, two things. And to Ned's comments about his environmental brother, I think there are some opportunities. This is an area where within our agency at IDEM, but also at the federal level, there are challenges at where it fits. Is it an EPA thing or a Department of Interior thing? Who does what? Doesn't really fit even within air, land, and water regulation. But I think there's some opportunities there as well. So, we're happy to, I think, do a deeper dive into some of the potential things, because I think the incentives are important, but the disincentives are probably more important. How do we address barriers or uncertainty? In areas like EPA, doesn't fit neatly in a box, but things like just saying concept of T-norm, technologically enhanced, naturally occurring radioactive material, which is one of EPA's concerns with rare earth processing. It doesn't fit perfectly in any of their respective divisions, but we've got some advantage. We don't have state regulations on things like that, but I think that's going to be an important tool, is to provide, a backstop of where this fits regulatorily. And then I'll say we got some helpful comments, I think, from in response to some of Governor Brown's executive orders on related issues where so folks, for example, from the electric utility industry said, hey, as we are developing and we'll soon have finalized a coal combustion residual permit program, which will be the best in the country to implement standards under RCRA. One of our concerns is we think this is great, but also if we have an open or closed landfill, a surface impoundment, what does it mean if somebody else is going to look for rare earth recovery? Who has environmental liabilities in that space? And so, agencies like IDEM should be looking at whether or not there's opportunities like we do with our state cleanup and other programs to ensure that those liabilities are correctly assigned to the responsible parties. And I think things like that would go a long way for certainty decades in the future, not just for maybe opportunities that exist the next year or two.
Absolutely. Great idea. Yes, sir. Todd.
So there's been a couple comments that have made here that there's a report that the Indiana Geological and Water Survey is working on, and Maria and her team, as well as Andrew and Kit, have also been part of that. And that includes everything from what do we have, where is it at, to environmental concerns that are out there, regulatory concerns. So a lot of the questions and things that you're asking about are coming out in a report that we have just a couple days ago into the Office of Energy Development, and they're doing a review of it right now. So I think pretty soon we should be able to lay out a fairly spectacular 120-some page report on answering many of the questions that you're asking here today. And I have to commend Maria for taking the lead starting in September. So we're being very proactive here, knowing that a lot of these questions that you're going to ask are actually, we can get to them right now and get answers for them. Well, we're waiting for the Office of Energy Development to get done with their review. And so they're going to try to do it as quick as possible. We've done our internal review, so we have that done. And then once they get done, we'll lay it out in a nice looking document for all of you. And it's last thing I looked at was 47 figures and 25 tables and everything that you want to know about rare earth elements and critical minerals. She's got the tome over there too. So
soon is the answer. Good.
Todd, one other quick question on that. I'm familiar with the report. I'd heard some details about it, but was that also looking at some of the processing innovation technologies? Is that included as they do a forward look? Okay.
Yes. Yeah, so we also discussing.
Press the button, Maria. Oh, there you go.
Yeah, we discussing the current technologies, and then we also discussing technologies that relate to our resource, specifically for different types. So we try to kind of indicate what would be the most maybe optimal or what's needed in order to address as best as possible our resource. So yeah, all of that is that, and then environmental implications and also economic. We kind of counted how many billions of dollars we have sitting in rare earth elements there, and kind of environmental and economic implications. So yeah, I hope it's a comprehensive report, that we try to put all the relevant information there, that we hope is going to be really a nice first step kind of to take, to look, and then decide what can we do next. Yes.
Thank you.
just to add on to that a little bit, the work that Maria's talked about and other things was all federal funds that were out there. So it was all pre-competitive science that we were able to do, and we've had it done and been working on it for the last 10 years. And now this opportunity comes forward to put it all together and hopefully to have Indiana advance forward ahead of others.
Fantastic. Any other comments from the council?
I was just going to make one other from previous in helping EV Products Commission as we were looking to catalog and consider opportunities in Indiana, to the point about not focusing on everything, but at least trying to get a collection of what's out there for available resources. I thought that was a really good thing that at the beginning, several of the commission members, we got together and agreed to help create kind of a listing. So building upon at that time, Purdue had done some reporting. We took Purdue's report, maybe eerily similar to what's coming about with this report, compiled a listing of Indiana assets and capability so that you had both the pre-information and great depth of information, plus a series of contact details that are out there. So I think it'd be great to catalog those. I will also say I'll stick my hand up and volunteer. We work with a ton of companies internationally in this space. We've got about a dozen clients we're working with that are doing refining techniques for acid water mine drainage, factory water waste, fly ash tests and others. So would love to help with volunteering to lead that effort on behalf.
Please, thank you.
To help with that catalog. And I think that's important for the commission so we can see what else exists above and beyond for available resources here within the state or attached to the state.
We'll take you up on that. Thanks, Ben. Any other comments, questions in the room? Okay, how about online? I'm not sure who's managing the online communication. Any questions or comments online? Okay. All right. Thank you very much. This concludes today, but I do want to mention just one thing. For our next meeting, we're thinking about having the Department of Energy's Office of Fossil Energy come virtually as we did today with the Interior Office and talk about the studies that they've done specifically on recovering from coal sites. So I think that would be a good next step. I also think based on what Maria talked about and what you suggested, Michael, it would be good for us to start inviting industry representatives to come and present to us, and we can ask them directly, what is it that would bring you to Indiana? What is it that's a good incentive for you to come to a state and start developing industry here in the state? And then I also want to put forth a suggestion to just start thinking about, last week we had a nuclear energy and economic summit at Purdue University. And the whole concept was with the goal of deploying nuclear energy and to bring nuclear manufacturing to the state of Indiana. So we didn't just invite nuclear developers, we invited developers, utilities that would deploy, EPC kinds of contractors, investors. We invited, who helped me with the others? Oh, the off-takers, so aluminum companies, steel manufacturers, AI companies that would, and we could see the side conversations that were taking place, people that would talk about putting together a project. And so I could see us having a summit like that on this topic at some point in the future, where we're inviting all of the ecosystem. And it's not about having a bunch of conversations and discussions. It's about bringing all those people who could develop projects here in Indiana and saying, we'd like to invite you to come here and set up this ecosystem. And let's talk about what we can do to bring you here to Indiana. So putting out those ideas, think about that. I think you all know how to get a hold of me and Maddie, and please send us your ideas moving forward. Thank you so much for a very productive kickoff to this council. I appreciate it. Thanks, everybody.